Being here, this south, it is what it is. The wind, we aren't up in Oz, but we're here, continuing our conversation about Great Salt Lake. So thank you for being here. We have a tight schedule. What else is new, Lynn? And we will have lunch across in the ballroom, but the breaks aren't scheduled. So if you need something, catering will have things out in that lobby, and you can go out and have whatever you want, bring it back in, or take a break. Okay, well, it gives me great honor to introduce Jaime Barnes, who is the director of the Division of Forestry, Fire and State Lands, and the title of State Forester as well. Is that correct?
That is correct.
Whoa, gosh. Where's Smokey the Bear? Anyway, so Jamie's going to tell us about the next, the work on the comprehensive management plan for Great Salt Lake, which is, yes, the next step forward in recognizing what we know about science that's been acquired, what we know about management issues that are necessary, and our resource as a public trust. So, take it away, Jamie.
Well, good morning, Jaime Barnes, as Lynn said, and it's a pleasure to be here this morning and talk with you a little bit about Great Salt Lake. As I was preparing this presentation over the last couple of days, I was thinking about Great Salt Lake and thinking about my time here at the division, and I was like, wow, it's been a minute that I've been here, but also the focus of Great Salt Lake has changed since I started with the division 13 years ago. So when I started, I like to say that Forestry, Fire and State Lands was kind of a sleepy agency. Everybody didn't know who we were, for right or wrong, but we wanted Great Salt Lake to be a focus, and it just wasn't at that time. But seeing everything that's gone on over the last couple days here, I have to say it's picking up. The focus is in the right place, and kudos to everyone that put this event together, because it's not easy to do, but the depth of the presentations that we've seen, it really makes me think that we're headed in the right direction, and I definitely know we are. So what I want to talk about today is the comprehensive management plan that the division is going to be working on, and how that interacts with all the other things going on Great Salt Lake, and how we're just looking forward and seeing what we can do to do things better. So first of all, I hesitated a little bit to put who Forestry, Fire and State Lands is in this slide, but I feel like there's still a little bit of disconnect on that. There's still some people who don't know who Forestry, Fire and State Lands is. I feel like we've made our fame, for right or wrong, over the last couple of years, but we are the executive authority for management of sovereign lands in the state of Utah. We manage the mineral estate other than on school and institutional trust lands, and we manage Great Salt Lake subject to the Commissioner Act with Commissioner Brian Steed and Tim Davis, and that's a great relationship that we share with them, and we're excited to work and coordinate with them directly on the lake, and it's been a great thing that's come into play. So let's talk a little bit about the comprehensive management plan and exactly what that is. This is a document that guides and supports and implements multiple use, sustained yield and objectives, and provides direction and land use decisions and activities on Great Salt Lake. This is going to help the division. Sorry, my voice gets a little bit cracky. Helps the division manage and allocate Great Salt Lake sovereign land resources. This is a tool. It's a tool for managers, it's a tool for researchers, and also for regulators to effectively interpret impacts on the lake, the actions that the division's taken on Great Salt Lake, and also the various lake levels that we deal with on Great Salt Lake. Also, we synthesize all the knowledge that's known around Great Salt Lake. So various knowledge that comes from people just like you in this room, learning what we have on the lake and putting that together all in one plan. It makes it really helpful for our analysts to be able to go to a plan and say, what do we need to do and what are those impacts? So overall, this is a guidance document for the division. This is something that our staff will be using daily. And we've had this document, but times have changed, and we'll talk a little bit about that and how they've changed. Many of us here know that they've changed, but it's time to start looking forward and figure out how we can make this document better. So as I talk through this, and I've thought this myself, we think more planning, really? How is this different? There's a lot of planning going on Great Salt Lake, and what are we learning from all that? And I think most of us have those questions. Do you do this document, do you put it on a shelf and we never look at it again? Well, hopefully not. We want something that's interactive that we're gonna be able to use. So last year, the commissioner came out with his strategic plan. They had a very short amount of time to do that plan. And it was a broad plan. It focuses on coordinated efforts, balancing societal and ecological interests, and we stuck some stuff in there on the berm management and how we're gonna do that. And that's really just until we can take a deep dive into our comprehensive management plan and how that works. And then Water Resources is working on the Great Basin Integrated Plan. They're doing a great job on that. They're not done yet, but that's ensuring adequate water supply for the entire Great Salt Lake Basin. So different than what we're doing on the Great Salt Lake Management Plan. And then out of this year's legislation, HB 453, water rights, was assigned a Great Salt Lake Distribution Management Plan. And I won't go into detail on what this is. I know enough about water law to get me in trouble, and Teresa will be up here telling me, no. So, but this is basically looking at water rights below the meander line and how those are distributed. And then the trust created their 5-year strategy to protect and enhance Great Salt Lake by leveraging public and private resources. So very different from what we're looking at in the comprehensive management plan. So last week there was an email sent around, and Laura Vernon I think is here, but she sent an email around also looking at these same things. So I think we're all on the same thought process of how much planning is going on and what is everyone doing, and I think it's helpful to take a step back and say, are we doing the right things? Is everybody looking at things? And number one, are we coordinating efforts? And that's really what we need to make sure we're doing, is that we're coordinating our efforts with everyone. And that's part of the commissioner's job, and he keeps a good thumb on that. And are we making sure that our efforts are aligned? And alignment is a really good part and key part of what goes on the Great Salt Lake. So let's talk about framework for the plan and how it's guided. So obviously code, rule, legislation, multiple use framework comes out of rule, highest and best use, impacts, compatibility. We'll be looking at all of those things. And then this last year, and also in HB 513 from the previous year, management responsibilities of the division were changed up. And not with regard to how we manage, but what are those strategies that we're managing for? Those were modernized. We're looking more at strategies for conservation now, not development on the lake. And so I won't go through all of those, but we're looking more at strategies to effectively and efficiently manage Great Salt Lake. We're looking for more healthy and ecological and physical conditions and how we balance those. So it's a different time, it's a different era. We're doing things differently now. So the need for an update. We've talked about this a little bit, but it's to account for a wider range of conditions. 10 plus years of change. Think about what you were doing 10 years ago. I don't know what I'm doing 5 minutes from now, but 10 years ago I was doing something completely different than what I'm doing today. But we need to coordinate management efforts with others, and that's a big portion of this plan, is to make sure that there's a coordinated effort, and that when we're making decisions on Great Salt Lake, we know that we're making the right decision and that it's coordinated across the board with other agencies. So what will be different? The 2013 CMP didn't account for historically low conditions that we've seen in 2022. Among other unforeseen conditions such as salinity. Salinity has been a big talk right now. We've developed the Salinity Committee. They have done a lot of work, and kudos to them for all the work that they've done. We're also going to address impacts across a wider range, talk about berm management, adaptability, define current goals, objectives, and implementation strategies. This plan is going to be actionable, adaptable, improve sustainability, and it's going to be interactive. It's going to be something that you can actually go to and you can get something out of it. And also, this is really exciting. It will be a new digital format, and it will be a tool that you can use. It will have a central database that's handy. You can use it right from your computer. And it's going to be pretty jazzy. I mean, I'm pretty excited about it. Right now, it's a paper copy that you can download as a PDF, and people sometimes want a paper copy. We can do that, but this will be more interactive and more modernized. And here's the matrix. So I really have to give Lynn credit for all the jazz that she gives the matrix. I can't tell you how many times I've seen her like walking into the speaker's office, explaining to him what the matrix is, and that makes me really happy because it's something we use. And so taking a deep dive into this and making sure that it's still accurate, probably doing something that we can actually read when we put on the screen would be helpful. So I think this is going to be awesome when it's updated. It's still going to be beautiful as it looks right now, but just really refreshing this and taking a look at it. Also, the Salinity Committee has created a salinity matrix that is almost as beautiful as this one. So also incorporating that into the plan. But these are helpful. They're helpful tools. They're something that we can get jazzed about, and they're something that we can use to talk about Great Salt Lake. I do have to tell you a little story. I travel a lot for this job, and I was at a fire conference a couple of years ago, and one of the other state foresters in another state said to me, hey, my husband's in water, and he works for a nonprofit agency, and they're doing some water transactions right now, and they've seen the Great Salt Lake Enhancement Trust that you all have set up. But they want to talk to you about that, but they also want to talk to you about this matrix that you have developed for Great Salt Lake. And so my point with that is the things we're doing here in Utah, they get noticed. This matrix that was developed by the planning team back in 2013, it's something that gets noticed. And it's something that I think people look at and think, wow, that's really cool. It's something that people can go to and they can be informed by it. So, and also, I love that Lynn is so devoted to the matrix. So thank you, Lynn. So let's talk about the mineral leasing plan update. As you know, there's a lot going on in the mineral arena right now, and it's been the talk of the session and of many other things. So this plan needs to create a framework for long-term policy direction and for mineral management that's adaptable to Great Salt Lake and informs on current conditions and reserves. It needs to account for the new legislation passed in 2013, HB 513 and 453. As you know, were huge bills that I probably thought we would never see on Great Salt Lake. So kudos to the representative for getting those past the finish line. This plan also needs to refine guidelines to help the division to manage mineral resources, both for economic and ecological benefit. And then lithium development. There's a lot going on here. There's things that we don't have answers to right now, and we're trying to get those answers. But being able to have a plan that people can go to and say, this is what I need to do to have lithium development on the lake, that's one of the key goals here. And then also talking about multiple mineral development. That's been one of the focuses of these bills that have been passed, and how do we balance all that? How do we balance it with ecological and economical? How do we balance it with public trust? It's all very complicated, but having a plan that will work around that is something we're trying to achieve. So we can talk about this plan, we can talk about everything in it, but how do we get there? And it's a process, it really is. So it involves involvement and outreach, and one of the biggest things that's really important to me is transparency. And we've got to be transparent in what we're doing. People just like you need to know the process, they need to be involved in the process, and we need to gather information from the experts. We're not the experts. There's people out there that know far more about this than we do. And so developing a planning team, having stakeholder involvement, having information sessions, public meetings, open houses, and comment periods so we can hear what we need to hear, know how we're doing, that's going to be important to us. Also releasing drafts of the plan to see how we're doing, what people think of it, are we getting it right? We'll also have this CMP Explorer tool, which is a landing page, public participation in that, complementary plans and studies, and also resource-specific information on that page. And then we'll be seeking input from all of you related to multiple use factors, such as the highest and best use, the present and future uses of resources, impacts, compatibility, and those special attributes and availability of resources on Great Salt Lake. So put on your thinking caps, start thinking about how you can be involved in that and how the information that you know will help us. So the timeline, this is a really easy timeline. I'm going to show you a little more complicated one next. But basically this is a 2-year process. We've just barely started this process. We have entered into a contract with Jacobs to help in the facilitation and consultation of this plan. So they will be doing all the heavy lifting on this for us. We've just started within the last month or so having meetings on this and just really sitting down and saying, what does this plan look like? How are we going to get to where we need to be on this plan? And talking about some of the things that I've talked about here today. But we're hoping by 2026 we can have a final. But throughout this process, people are going to be involved and you're going to see what we're doing. And here's a more detailed timeline, which I won't go into detail on, but we can get a copy of this PowerPoint out to anyone who would like it. And this breaks down more of the tasks in details and when public involvement will be happening and what exactly that will look like over the course of the next couple of years. And modern day technology always involves a QR code now. So if you want to get your phones out or get a copy of this, here's a QR code where you can scan this. It will take you to a little SurveyMonkey link and you can put in your information, and this will allow us to keep track of your information and keep you informed as we go through this planning process. So this is really important to us to be very transparent to you and make sure that you're involved. And we're really excited about starting this process and really making a better comprehensive management plan for all of you and for the division. So with that, I will leave this up here for just a second more. And then I will tell you, if you have questions, call Ben, because he's not here today. He has a sick kid. So, and that's all I have for you. If you have any questions, I am happy to answer them.
We have about 10 minutes for questions.
Okay.
My question is, well, first of all, it's great to have a Great Salt Lake Commission, would you agree? And helping the lake kind of extend the reach of connectivity in the watershed is profound. So we've come a long way, big. That being said, with the process for the comprehensive management plan, and one of the things that I think has become more evident as time has gone by with Great Salt Lake and the shoreline and dynamics at play that are impacting hydrologic connectivity, that wetland upland interface that's so much a part of the Great Salt Lake ecosystem. Those kinds of things will probably emerge in the outreach and the process of public input. And I think with the commissioner, the hope is that that recognition of that landscape relationship can be translated into some effective management outcomes as well. Would you agree?
Oh, totally agree. Yeah, I mean, we have to take all of that into consideration because it's not just below the meander line, it's everywhere that is impacting that. So yes, that will definitely be part of it. Totally agree.
Thank you so much for your endurance,
Yeah.
your perseverance, your commitment. And I remember, I think when I first met you, and you were focused on the mineral lease plan at that time. And that in and of itself, I mean, your remarks about how we've come so far with HB 513 and HB 453, a recognition of, maybe sustainability, I think, is probably the MO that we can use these days.
For sure.
So it's very heartening and it's promising. And, thank you for your work.
Thanks, Lynn.
Good morning, and thank you so much for all of your work and the wonderful information, and thank you to everyone for your patience with my many questions. I'm just curious to know, you talk about maintaining good coordination with the different plans and agencies, and I'm just curious, what does that coordination look like, and how do we ensure that it happens?
Yeah, so I think a big part of that, number one, is the commissioner's office, but two, it's with the consultants that we have, but it's also on the divisions individually, our office specifically, making sure that we are coordinating with those other agencies. So we can't expect that other agencies are coordinating with us. We have to make sure that we're coordinating with them. So keeping track of what's going on in other agencies is super important, and just making sure that that outreach is happening. But I do have to say, the commissioner's office has been really good at wrangling all of the people to make sure that that coordination is happening, but also reporting to them what's going on within each of those agencies is really important. So it's really a due diligence factor to make sure that we're all making sure that we're talking, because in any job, in anything we do, even in our personal lives, communication is key, and that's how things work and how things get done. Yeah.
If I understand correctly, you guys manage the road, right?
We do, yeah.
So what kind of discussions we're having this year with another wet year? Were there discussions to raise that, to maximize this all of that?
Yeah, so Ben Steierman would actually be the better one to answer that question, but my understanding right now is that they're gonna leave that right now and see how that progresses out. And those conversations have been in the Salinity Committee, but that was my last update, that they're gonna leave it for right now. Anything else? All right, well, maybe you guys can get some coffee and donuts, or I don't know, sugar up for the next one. Thank you.
Good morning. Thanks so much for being here on a Friday morning on day 3. I'm Janice Gardner. I'm the Executive Director at Sageland Collaborative. I'm speaking today on behalf of our ecologist, M. Clark, who couldn't be here today. I also wanted to mention that today is my birthday. And I bring this up because honestly, I can't think of anything better than talking about birds with people. And I also bring this up, I'm going to be at the banquet, so to the cash bar, y'all can buy me a drink. And I'll let Max introduce himself.
I had no idea it's Janice's birthday. Good morning, everyone. I'm Max Malmquist, and I have a little frog in my throat this morning, but I'm the engagement manager for National Audubon Society Saline Lakes program. And I fell in love with birds about 12 years ago, and over the past 5.5 years, I've really discovered my passion for the birds of Great Salt Lake, and in particular, shorebirds. And for those of you who are here early this morning, you got a taste of Lynn's jokes. So I've always tried to think of how to categorize Lynn's jokes. Are they dad jokes? They're kind of unique. Well, maybe we just call them Lynn jokes, but I've always wanted to kind of come up with my own Lynn joke for the birds, or a bird of Great Salt Lake. And I had a little help with this. My comedic career might end here in about 30 seconds, but so Lynn, this is for you. But why did the Phalarope cross the globe? To get to the other brine. I'll keep working on it. Oh, great. Thanks. I did have a little help with that. So we'd really like to acknowledge our incredible network of partners who have really helped both fund and support this program over the past 2.5 years, or 2 years. This includes in Utah the Great Salt Lake Advisory Council, the Division of Forestry, Fire and State Lands, Tracy Aviary, our local Audubon chapters, the private duck clubs. But we'd really like to highlight our partnership with the Division of Wildlife Resources and the Great Salt Lake Ecosystem Program. They have provided major in-kind support. I see John here. I don't know if John left too. Russ, your guys' teams have been incredible, from helping us with coordination, to survey design, to doing aerial and airboat surveys. You name it, they've done it. We couldn't do it without you. And then outside of Utah, we've partnered with over 70 organizations to make this program possible. And these types of surveys haven't been done for 30 years. And so we have this big data gap, and with that, it's become a priority for the U.S. Fish and Wildlife Service as well as the Pacific Flyway Council. So the Intermountain West, or the interior portion of the Pacific Flyway, contains wetland habitats that are critical stopover sites for many species of shorebirds. And the shorebirds, they use these sites and their food resources sometimes just for a few days to a few weeks during both spring and fall migration. And without these sites, without places like Great Salt Lake, these shorebirds would not be able to survive their migratory journeys, full stop. They need these places to stop and rest and refuel. So the vast majority of the sites that are associated with this program are freshwater wetlands, but the largest, most important stopover sites are saline lake ecosystems like Great Salt Lake. And these habitats are unique in that they have superabundant food resources that support incredible numbers of birds. As you can see here in this lovely photo that Janice took of blackneck stilt, and it's surrounded by a smorgasbord of brine flies. And let's see if I can get this video to work. Oh. Okay, well, in this video you would have seen some Wilson's Phalaropes, which you've heard about a little bit. Oh, thank you, Katie. In the last couple days, and I think Marcela is going to be speaking to them in a little more detail later this morning. But these are a species that heavily rely on saline lakes throughout their annual cycle. And you could see them in that video there picking those brine flies off the surface of the water. So the goal of the Intermountain West Shorebird surveys is to evaluate migratory shorebird distribution and abundance, not only here at Great Salt Lake, but across the Intermountain West, in order to provide a foundation for management of resources for shorebirds. And these shorebirds are spread out across the entire hemisphere during their annual cycle, from Tierra del Fuego in South America all the way up to Siberia. And during migration at these migratory stopover sites, we have this unique opportunity where these birds are, they're funneling through a more defined landscape. And it gives us this opportunity to get a decent idea of how their populations are doing. But in order to do that, you have to have people out at all of the sites all at the same time counting these birds. And so with this program, we have three scales of questions. So the regional scale, what sites are shorebirds utilizing and why? How does this compare to historical averages? And how has wetland habitat and surface water changed over time? What is the value of a particular site compared to others? And then second, zooming into the Great Salt Lake ecosystem, what sites around Great Salt Lake are shorebirds utilizing and why? This is especially important because we are faced with making decisions about what places get water, when, and how much. And we need this information to inform management actions and policy decisions. And then even more fine detail, the individual wetland sites. So we are doing some surveys at some of the WMAs and individual wetland impoundments, and looking at habitat variables and management like Phragmites to help us understand how shorebirds are responding. So this is a map of our project area, and I mentioned the historic survey from about 3 decades ago. They had 162 wetland sites across 7 western states, and we've added about 40 sites and have in 11 western states, so we've expanded that scope to include the full interior of the Pacific Flyway. And our project area is basically bounded on the west by the Cascades and the Sierra Mountains, and more or less on the east by the Rocky Mountains.
Okay, so out of those 200 sites, Great Salt Lake, the entire ecosystem is thought of as just one site. But actually, it's about 68 subunits. And this is basically 700,000 acres. That's the size of Rhode Island. And like Max mentioned, we weren't the first ones to come up with this survey. All the way back in the 1900s, a time before the internet, smartphones, there was a group led by Shuford et al. Also, Don Paul was a big part of this that started the Shorebird survey. Of course, this was only 30 years ago, but that was the 1900s. It feels like a long time ago. And this is what the Shorebird survey looks like today. Can I get a hand raised for any of my Shorebird surveys out there? I know there's some of you. Oh, yay. So what this looks like today is we go out in the fall migration and the spring migration. During the spring migration, birds are really excited, i.e. means they're ready to have sex. And they are moving through our region very quickly. They're trying to get north to their breeding grounds. So we have a 1-week window across the whole region to get the shorebird survey done. Here in Utah, we do this on one big day. In the fall, the birds are moving a little bit slower. They've done their life's purpose already. So we have a 2-week window to get that done. These windows were selected from a science team that picked peak abundance and also species diversity from data from the past 10 years. Are these windows perfect and going to capture every bird species? No, but they're pretty dang good, and we'll talk a little bit more about that. We've got people on, we've got the Johns at the ecosystem program that are up in airplanes. We've got airboats, we've got ATVs, we've got people on foot. We haven't had anyone on a bike or a scooter yet, but or ice skates or anything like that. So, and I'm happy to share just a few preliminary results with you all. So first, a few caveats. This is really interesting. This data set shows the pendulum shift of the fall 2022 when we were so near the collapse, and then this incredible spring runoff. It's important to note that the numbers that we're sharing really are raw data, so they haven't been corrected for the amount of area that was observed by our surveyors. And this goes not just for Great Salt Lake data, but across the region. However, this is still incredible data that I'm happy to share with you. And like Max mentioned, we do have more sites than we did 30 years ago, at least across the region. But at Great Salt Lake, we really have an apples to apples from 30 years ago, which is really exciting. Okay, let's go back to fall of 22. This is the wetland evaluation tool. If you've never used this product, it's a data product from the Intermountain West Joint Venture and Patrick Donnelly's lab. It's really cool, so make a little mental note of that. The dark blue on this map is where the actual surface water was. So you can see places like Farmington Bay are just this tiny little ribbon, a former of what they used to be. So when we counted shorebirds, fall of 22, we still came up with 228,000 shorebirds that we counted across one big day, which is really pretty incredible. Another thing that's of interest is that 75% of the birds that we counted were actually on lands managed by the Division of Forestry, Fire and State Lands. And maybe, talk about changing of the plan 10 years ago. Perhaps the division didn't think that they were a shorebird manager 10 years ago, but now they certainly think of themselves as a manager of shorebirds along with their peers at the Division of Wildlife Resources. Phalaropes, really abundant species, and then American avocet was our second most abundant. This is the type of map that we can produce, not just for all shorebirds, but for individual species. We're going to highlight just two species in a species group today. This map on the purple is low numbers. The greens are higher numbers, and then the hashing is no shorebirds counted. So this is for American avocet. You can see places like Farmington Bay. Really, this is where these birds are using. Let's look at phalaropes from fall 22. I think it's really interesting how important the west portions of the lake are. Those are places that are probably have a lot of productivity for brine flies. There's a lot of microbialites out there. Okay, we're moving into spring of 23. We have a lot more water. There's a lot more dark blue on this map. And everyone in this room, I think it was just it was very emotional for me that we got that winter that we did. How did that even happen? I don't know, but wow. Spring, we had 84,000 shorebirds, and the lower numbers were seen across the region, and that's because a couple things. Birds are zipping through here a lot quicker, so seems like we tend to see less shorebirds, and also in the fall we've got a lot of young of year birds, so that's adding to the population. Again, phalaropes abundant as our American avocets, and Division of Forestry, Fire and State Lands birds are still really loving the property that you all manage. Here's our American avocet. Again, Farmington Bay seems to be a really popular spot for these birds. And phalaropes, same for them. Okay, now we're on to just this past fall. We've got lots of water in the lake still. We counted more shorebirds in fall this past year than we did in 22, which is exciting. Again, avocets using eastern portions of the lake. And our phalaropes. Farmington is still lighting up in green, but western parts of the lake are still pretty popular. Okay, I'll turn it over to Max.
Great, thanks, Janice. And so now we're going to switch gears a little bit and look at some of our preliminary data from across the region. So this is a map from our first season of surveys in August of 2022. And I will note, this was our pilot season of surveys, so I think we ended up surveying about 110 sites. We're still building out our network and really focused on some of our high priority, big complex sites. You'll note here, you might not be able to see in the back, but the little gray circles, those are sites where we either didn't survey or we counted 0 shorebirds. And then all those other colors represent how many shorebirds were counted, and the size of the circle is relative to how many birds were counted across the region. So two things I want to point out here. Notice where those big circles are. You'll start to see a pattern. And then also that, let's see, the size of circles, and then I'll think of it. Sorry, drawing a blank. So skip ahead to spring of 2023, and you can see a lot more yellow dots. We've filled out our network, and again, look at those big circles. And at Great Salt Lake, for all the shorebirds counted across the region, Great Salt Lake hosted about 47%. That was what I was going to note here. In our first season, about 51% of the birds were counted at Great Salt Lake. And then this is from our third round of surveys in August of 2023. And something I wanted to note here, that big circle at the bottom, Salton Sea. So if you were here yesterday, you may have heard the presentation on Salton Sea, and the levels of the sea continue to drop. We're seeing a change in habitat. There's more exposed wet lake bed and mudflat, and we're seeing the shorebirds respond. And during the historic surveys, the maximum count in fall at Salton Sea was about 105,000 shorebirds, and they counted over 250,000 last August. So something that we're keeping an eye on. So that pattern, those big circles, again, just the importance of these saline lake ecosystems. They support hemispherically significant percentages of shorebirds. And in our first 3 seasons of surveys, between 88 and 90% of all the shorebirds counted across the region occurred at these 7 ecosystems in 4 western states. And just a couple of things to note here. If you take a look at Lake Abert, these saline lakes are resilient. Lake Abert over the past 10 years has almost completely dried up a number of times. During our first 2 rounds of surveys, it was almost completely dry, but then in fall of 2023, water levels rebounded a little bit, and you can see that the birds responded, almost 20,000 birds. And then again, Salton Sea. These systems are very dynamic. They're always changing, and little different circumstances, but the sea dropping, but we're seeing that change in shorebird use and abundance. All right, so spring of 2024, our spring window just ended about a week and a half ago, and so we do not have some updated data for you yet. We hope to have some updates coming this summer, but I just wanted to mention that we had a really wet and windy spring window this year, but despite difficult conditions, our amazing volunteers, they braved the weather, and we were able to conduct a successful survey across the region and also here at Great Salt Lake. And I think between the day before our survey and we ended up doing our Great Salt Lake survey on our backup day, I think there was over 2 inches of rain on the lake. So yeah, very wet. Okay, just a quick look at some saline lakes and some of the specific species that heavily rely on them. So here we have data from August of 2023 for American avocets. Just really quick, want to highlight the importance of Great Salt Lake and its wetlands to the species. And then again, phalaropes. The Wilsons and redneck phalaropes heavily rely on these saline lake ecosystems, including Great Salt Lake. You can see over 200,000.
All right, let's take a little peek at some of the data from the yesteryear to today. So fall migration in between 89 and 95, they were reporting a median number, 670,000 shorebirds across the entire Intermountain West region. We've only got 2 data points, fall 22 and fall 23. And across the region, we had 370,000 birds and 727,000 birds respectively. So we're really excited to build out this data set a little bit further, and hopefully we can help understand some trends in shorebird numbers across of our region. So in spring, 89-95, 270,000 birds was the median that they counted again across the whole region. And we just got 1 data point, 1 more pending, and little bit lower number, $170,000 shorebirds. Just looking at regional data before and now at Great Salt Lake, in the 1980s and 90s, blackneck stilt meeting numbers were about 50,000 birds. So far, our data points looks like we could be a little bit lower. Same thing for avocets, we could be significantly lower. Marbled godwit on there, also we're not seeing his numbers as high as they reported 30 years ago. And interestingly, the Phalarope numbers, there's an interesting story in there that we don't have the answer yet to. So we're really excited to keep furthering this data set.
So something that we really wanted to highlight is that there are a number of complementary efforts that are going on that will help inform our analysis for this project. Janice just mentioned the Phalaropes. Marcela is going to be talking a little bit more in detail about some hemispheric Phalarope surveys that are going on. But one of our partner organizations, Point Blue Conservation Science out of California, they've been leading a project called Migratory Shorebird Project, which includes the Pacific Shorebird Survey for a little over a decade, I believe. And they're just getting ready to publish a paper looking at the shorebird trends on their wintering grounds on the Pacific coast from North America all the way down to Chile. And in this graph here, you can see towards the bottom, one of the species in particular that is showing significant declines is the American avocet. And this is a species that historically has relied very heavily on Great Salt Lake and its wetlands, with over 50% of its global population, both breeding and staging, occurring here at Great Salt Lake. And so we'll be looking at this and other data sets to help fill in some of the gaps for the shorebirds during different portions of their annual cycle. So what's next? We're going to continue to conduct shorebird surveys over the next couple of years. We will plan to refine our counts and our estimates. We'll have more robust regional comparisons, including species-specific comparisons. You saw those maps with the Intermountain West Joint Venture's wetland evaluation tool. We will use that to compare our counts to surface water coverage across the region. And then here at Great Salt Lake, we will compare shorebird distribution to Phragmites mapping, coverage, and management. We're planning to work with Westminster's Great Salt Lake Institute, who you heard a little bit from yesterday, to coordinate our surveys with their brine fly research. And then ultimately, we hope that these data will help prioritize wetland and water management, not just here locally at Great Salt Lake, but across the region. And with that, thank you very much, and we're happy to answer some questions.
The preliminary data and the list of your survey sites. Why was I surprised to see Owens Lake with such a significant number of shorebirds?
Great question, Lynn. So for those of you who are familiar with Owens Lake, they've spent a lot of money doing a lot of mitigation. And if you talk to people who have been around Owens Lake, they've actually created a lot of shorebird habitat. So they have individual management units. Some of them are gravel or other ways for dust suppression, but there's quite a few of them that are actually shallow wetlands. And so that's one factor. And then also with the really wet year, record-breaking snowpack that they had in the Sierra last year, Owens Lake is a lake again. So that might be a factor as well.
And I'll just mention that is what is so incredible about a survey like this is you can really kind of compare apples to apples and really understand the value of individual wetlands. And it's just really can't be done unless you've got a huge, huge collaborative partnership of people that are getting out all at the same window.
Yeah, I just wanted to make a comment. Could you go back to the slide of Phalarope distribution?
On the lake?
Yeah.
This one?
Yeah, and just when we look at that, and you see particularly, as you noted, on the west side, there's a lot of Phalarope habitat because there's a lot of microbial life. You've got a causeway there, north of it, no Phalaropes. There's microbial lights up there. I crashed my boat into them, so I know that. And the comment is that we think of the lake as the norm is 4,200 feet, and at 4,200 feet, the north part would still be hypersaline and any active growing microbialites or birds up there. But if the lake was 11 feet higher, the salinity would be a lot lower. And so the point I want to make is that, well, we lost about half of the Phalarope habitat by losing the north arm to effective production. So we just need to keep that in mind when we're thinking about the lake and managing it.
Thanks, Wayne. Great point.
Great work, you guys.
Great work, you.
I actually almost had another question. I was curious if there was any information on the North Arm from 30 years ago with Shorebird, or if it's just overall.
Yeah, so what's interesting about that historic survey, and so that Shorebird paper, it was led by then Point Reyes Bird Observatory, which is now Point Blue Conservation Science. And Janice and I actually met David Shorebird at Mono Lake last summer. But one of the challenges that we have is really all that was documented was the paper itself. They didn't document the routes they took, they didn't document individual survey areas, anything like that. So that's one of the things that we're trying to accomplish with this survey now, is that we're trying to document all of that so that if we want to do this 5, 10, 15 years from now, that we have that information so we can do more apples to apples comparisons like that. So.
Okay, now for
I was gonna say, but if we can find out where Shorebird lives, we think that the data is in a filing cabinet. Maybe we should do a raid for conservation, so. He's still amongst us.
better get that in a hurry. Okay, so my real question was with respect to the avocets. I'm curious because it looks like the numbers have diminished considerably. I want to know, or if there's a way to even look at the 5-year waterbird survey that Don Paul initiated, and look at Phragmites expansion since that time, because I think that's probably a major contributor to the lack of avocets.
Yeah, and I don't know if folks really appreciate how devastating Phragmites has been to bird habitat on Great Salt Lake. So I'll answer John's question by saying we have a graduate student with a new professor at Utah State University, Dr. TJ Clark-Wolf. She's going to be, the graduate student's going to be coming on this fall, and we're just so excited to be diving into questions just like that and really pulling a lot of other data sets from across the region and even here at Great Salt Lake to really tell the story of what's going on with our shorebirds and how we can best protect them.
Good morning. Thank you for excuse me, all of your work and wonderful presentation. I am curious to know to what extent, if any, does the presence or absence of certain bird species serve as a gauge for the health of other species, or is it more just sort of that they tend to be there or not be there together?
Great question, and I think it was mentioned yesterday with the Fly team that Utah's going through their wildlife action planning process right now, and there are, shorebirds are unique. They have different leg lengths that allow them to utilize different depths of water. Of course, their bills, same kind of thing, take advantage of food resources, but there are species that overlap quite a bit, and so even going through that wildlife action planning process, there's certain species that we can kind of use as an example for a suite of other shorebird species. And as far as analysis and data, something that we should think about.
Thanks for your work. I'm wondering if you've noticed any differences in the timing of migration patterns of these species?
So Janice mentioned Audubon's National Science Team. We looked at 10 years worth of status, eBird status and trends data to help us to come up with the peak timing of both diversity and numbers for about 30 common species that migrate through the region. And you know, I don't know like necessarily the timing has changed across the region, but what we are seeing is that we're not hitting some of these species because of weather. So just for example, last spring we had really good numbers timing-wise for avocets and stilts and marble godwit, some of the larger shorebirds, but we really missed the peak of some of our longer distance Arctic migrants. And this spring, we missed the larger shorebirds, but it seemed like maybe we also missed those Arctic migrants. So I think the weather plays a role in the timing, but that will also be something kind of interesting for us to look at is overall, you know, has the timing for these birds and their migrations changed? And I think we're out of time, so we'll be around to answer any other questions. So thank you.
Thank you. So I'm Dan Smith. I'm a waterfowl scientist for Ducks Unlimited, and today I wanted to share some of what we work on and how we really manage an international resource through local actions. And when I'm talking about international resources, I'm of course talking about waterfowl. We just heard about shorebirds, but waterfowl are an equally interesting group of species, I think. We typically, when we refer to waterfowl, we're really talking about 34 different species of ducks and geese that migrate across habitats, cross international boundaries, and use wetlands from Mexico all the way into Canada, and for some Arctic nesting geese, as well as Russia and Japan. So the suite of species have a bunch of challenges when they move through the continent and try to find habitat. And when we're thinking about managing these populations, we often think about population demographics. How do we influence things like survival and recruitment to ensure that these populations stay resilient over time? And it can be easy to forget how past legislative efforts have really had major impacts on these things, one of which was regulated hunting in 1918. It was a long time ago, but it really had a huge impact on waterfowl populations. Prior to this, market hunting removed a huge number of individuals from these wild populations. They were a heavily sold market item in San Francisco and all across the United States. And with regulated hunting came a massive reduction in that removal source, and now winter survival is the highest point, or it's the highest survival rate that we see in these wild populations. But we can't regulate or legislate birds to be productive on nests, to survive in breeding grounds, so we have to think of other ways that we can influence these populations. And that's really through habitat and habitat management. And when we think about habitat for these species, you're not thinking about a single type of habitat. These aren't localized species, as I said earlier, they're migratory. And so they need different types of habitats all across the season in very different areas. Nesting and brood rearing habitat looks very different from molting habitat, which is very different than staging habitat. And to access these different areas, they're typically traveling thousands of kilometers and occasionally thousands of miles between breeding habitats and overwintering habitats. So when we're trying to manage habitat, we really have to answer some critical questions in when and where do these habitats need to exist for these waterfowl species. And I think being here in Utah near the Great Salt Lake is a great opportunity to really talk about some of the first ways that we tried to answer these questions. In the early 1900s, bird banding began. 1909 was that systematic banding effort. And for those folks who maybe aren't familiar, bird bands are just aluminum bands you place around the leg of a bird when you capture it, and it has a unique ID number. The USGS Bird Banding Lab handles all of this right now. It's an amazing data resource. It goes back a very long time, so you can ask some great historical questions with it. And one of the first questions that was really answered was, how do we understand these migration pathways? And as I said earlier, Utah was a huge influential part in this because of the Great Bear River marshes had a huge breeding population of redheads. And some of these redheads were really defining where we established migration routes. And Frederick Lincoln here is in the black and white picture, like any biologist, a nice staged picture with all his bird bands and his banding pliers right there. I don't think he did that on a regular basis, but he was able to summarize some of that first couple of decades of data and really establish what we know now as our 4 core flyways: the Pacific Flyway, Central Flyway, Mississippi, and Atlantic Flyway. And these were really published in 1933, so they've been around for a long time. And I guess one of the things I really like about going back to this paper is now, since it's a historical archive, it comes with this big disclaimer on the front page that says historical data do not apply to current situations. But these migration routes, we've learned a lot more about them, but they stayed more or less true. I think one of the interesting things that really came out of this work was really establishing that breeding grounds for waterfowl typically lie to the north, and a lot of southern areas, really the lower 48, is where we think about a lot of wintering habitats. And the work that he was working on at this time was really to try to understand why populations of waterfowl were collapsing. They regulated hunting, it's been a couple of decades, but populations were still not rebounding. And it was very apparent that another driver in population decline was habitat loss. This shows every one dot is 20,000 acres. And most of these areas were drained for agriculture, and really between 1750 and 1980, it's estimated we've lost over 120 million acres of wetlands. So that is a huge amount of landscape that used to be available for not only waterfowl, but shorebirds and a bunch of other species as well, that was lost. And so when we think about trying to maintain these populations, we have to think about how do we make the most of what's left, and how do we make sure it's productive? How do we make sure we're not just providing a bunch of marginal habitat to these species? And this was something, again, that was worked on really early on. This was a waterfowl food plants management book that was published in the 1930s. More Game Birds in America Foundation, that's actually Ducks Unlimited before we changed our name. I think it was a good change. And you can see these guys really told managers, waterfowl managers, wetland managers, how to create wetland conditions that were productive, how they were producing plants on that landscape that would really feed these populations. And it really had a big impact. We saw a lot of different habitats go from marginal kind of okay spots to really, really productive areas that were able to support these waterfowl populations. And when we think about supporting waterfowl populations, you really have to talk about the winter food limitation hypothesis. You can call it a hypothesis, it has proof, it's fun to argue about, but at the end of the day, what we really see here is body condition or lipid reserves, which waterfowl use to fuel their migrations and these big life cycle events, have been correlated with food abundance. And that body condition has also been shown to impact things like survival, migration timing, and migration success, as well as breeding success and ultimately recruitment. And at a very basic level, we can also see populations are typically congregating in areas where there are very productive food resources. And so this idea and this evidence really provided linkage between continental populations and habitat conditions. And this type of data and effort that was gone into this has really shown that what we do to landscapes can impact populations at a very consequential level. And so when we think about these linkages and we think about wetland management, we think about how do we manipulate these landscapes to ensure that populations have access to the resources they need. And when we think about what levers we can actually pull when it comes to wetland management, it's only a few. We can really control water and some disturbance. And what we're trying to do with these levers that we can pull on these landscapes is really recreate conditions that are no longer there. Oftentimes these wetlands are in very degraded hydrological systems. There's been a lot of channelization, there's been damming of rivers, huge demand on water resources. And so when we try to recreate these landscapes or reconcile these landscapes, we have to think about replacing these historically provided conditions through management actions and things like infrastructure. And many of these areas are manipulating hydroperiod and disturbance to create conditions for plants to germinate. We're really trying to grow wetland plants, native plants, that these waterfowl species and other species really benefit from. And a lot of this work has been, as I mentioned earlier, they've been thinking about this since the 30s, so we think at this point you probably have a pretty good grasp of things, but as Leif Fredrickson, who's really kind of the godfather of wetland management in North America, has always pointed out, it's much more of an art than a science. There's so many variables involved in this that you can never have a predicted outcome. This isn't a monoculture of corn where you're providing a bunch of conditions that are going to be perfect for that whole crop. you get a variety of different outcomes based on all sorts of different conditions that present each year. And we continue to study this and produce wetland management guides based on the science. And I think something that's interesting is, as time has gone on, we've actually done more and more research on this in more and more habitat types. So things like agricultural landscapes and moist soil landscapes were kind of our bread and butter in the 90s, really 80s before that. But now we're looking at playa wetlands, semi-permanent wetlands, more and more tidal wetlands, and I'm sure brackish wetlands in the future as well. And all the research that we produce, usually at a university level or a research institution level, tends to make its way and trickles down into an applied source, where we build these management guides, both for state and federal agencies to use and produce themselves, as well as different organizations that have the intention of ensuring that what few wetlands we have are well managed, and that management is really guided by science. And I think something that can occasionally be lost is, although state and federal agencies really do put a huge effort into making sure wetland management is proceeding and working the way we hope it is to support these populations, a huge burden is actually on private landowners. And they actually take this on willingly, seek out these resources, and try to provide these habitats for waterfowl throughout the year. And in Utah alone, I think about 50% of your wetlands are privately owned. And so that's a huge landowner group that could be, needs to be well educated and guided by science to ensure that those landscapes are providing the outcomes that we expect them to. And while we often think about these outcomes in terms of waterfowl, due to how we're researching these things, you would think over the last 70, 80 years that we've been doing this, that waterfowl populations are doing great, that they're resilient. We've provided a huge amount of landscape, huge amount of science to support these populations, so they should be resilient into the future. But waterfowl are a tricky species to manage. One of the nice things about waterfowl, and this is a quick plug for anyone who's looking for a research organism, shorebirds, there's been extensive population monitoring for decades. We've really been doing this since the 50s, both banding efforts, spring surveys, habitat surveys, population counts at the continental level, so we can really track these things through time and look at different habitat covariates and see what influences these populations. And what we've seen is they're very responsive to habitat conditions, both in breeding areas and wintering conditions. So whether there's drought, whether there's landscape change through agricultural conversion, populations can fluctuate in a handful of years by 20 million birds. So that's a huge shift in a very relatively short period of time. So waterfowl are trending in an okay direction, maybe not in the last few years, but it really speaks to the importance of continuing to manage these landscapes to ensure these populations can be resilient. And one paper that actually just came out very recently did some of this work, and they actually looked at this longitudinal data set with landscape cover as well, and found there was a lot of correlations between surface water in winter, as well as breeding condition, grassland access. Patrick Donnelly's wet model was actually using this. I'm glad it's being used elsewhere. Really interesting tool, and then we're really kind of just at the tip of the iceberg in looking at that tool and evaluating some of these longer term data sets. But with ducks aside, the wetlands that are managed for waterfowl also provide other services that we often don't quantify, or we haven't tried to quantify until recently. Some of the work with my counterparts in our national headquarters, Alan Herbert in particular, has really looked at how these waterfowl wetlands, as we typically refer to them, provide a suite of benefits that people and other wildlife species really can take advantage of. When you have these wetland systems that produce productive plant communities, we also see native pollinators need those areas We can see that these managed wetlands provide lots of flood attenuation. Because of the infrastructure, we can guide high stream flows into these areas to ensure that populated areas don't have the consequences of these high rainfall events that we tend to see more and more frequently. They provide a lot of groundwater recharge in a lot of areas, as well as filtering. Sedimentation can be reduced by putting the water on these landscapes, slowing that water down. And ultimately, as that water enters these landscapes, becomes shallow, stops moving quickly, we see a lot of productivity that benefits native fish species, and a huge amount of inverts use these areas as well. And it's really that core food source that benefits many more populations beyond waterfowl. And it's important to remember that with these managed wetlands, we're really trying to replace natural infrastructure. These areas have been lost, And in many cases, we're trying to restore them or recreate them or try to reconcile the landscape that we have so that whatever area we have of wetlands is extremely productive and is extremely efficient at providing the benefits that we really need from these wetland areas. Now, we've been talking about water challenges in the West. It's a common thing, and wetlands are no different. In the West, in the arid West, really, our wetlands depend on surface water flows. About 80% of waterfowl habitat depends on surface water flows in the West. And so if we don't have those flows, those waterfowl populations could be leaving really productive breeding grounds in Canada and the boreal forest and find almost no landscape to utilize in winter. So that's a very possible outcome with big consequences. And when we think about wetlands in the Great Salt Lake, we can really think about it in two kind of ways, where we have these unmanaged wetlands in the black shaded areas, and the managed wetlands in the gray shaded areas. And these are no different than many of the arid West wetlands that we see. They're heavily dependent on lake levels and water deliveries to ensure that these areas remain available and productive for all sorts of different species. And it was great to talk or to hear about some of the shorebird work looking at all these different areas. A lot of these areas are really important for waterfowl. They seem to be very important for shorebirds as well. So we're achieving some of these multi-species benefits potentially by accident. And we can be more intentional about finding those commonalities, whether it be over time, whether it be target depths, whether it be plant species compositions, to really make sure what limited footprint we have is able to provide wetlands for the suite of species that really depend on them. And sometimes when you look at images like this, you can see how large the lake can be, assuming lake levels are high, and think that the limited shaded gray areas may not be relevant in a continental level. But when we think about how limited the total wetland area is in the West, just due to the geography that we have in the West, a lot of high mountains, a lot of high desert, there's not many areas where wetlands could exist here. And so we really have to protect what areas currently have wetlands and what may have wetlands into the future. And when we think about wetlands from a conservation planning perspective for waterfowl, we really think of these, what we call the big three, which is Southern Oregon, Northeastern California, or really the Klamath area, the Central Valley of California, and the Great Salt Lake. And if we lose one of these pillars, waterfowl populations and really Pacific flyway birds in general are going to be in big trouble. And we can know this just from some of the survey data we've had from waterfowl. Between September and April, about 70% of waterfowl species use at least one of these areas. So if we lose one of these areas, there's no extra place for them to go. There's no other area that can support them. And one of the things that I'm really excited about, banding waterfowl is great, but you only really get 2 locations where it was banded and where it ended up. And what we're seeing now is some awesome work coming out from the GPS GSM transmitter backpacks that ducks are able to wear. They're a bit hardier, heftier birds. You can give them a heavier transmitter and it won't impact their daily migrations or yearly migrations too much. And what we can see is in this map here, all these yellow areas are showing you where waterfowl are moving in the Pacific Flyway. Now this is a bit of a caveat I'll make here. California is so heavily lit up right there because that's where transmitters were put on these birds. A lot of these birds were white geese. You can see the use in Wrangel Island over there, northern Russia. Most of those are snow geese and Ross's geese. So a bit of a bias in that, and of course a bias in the fact that we weren't banding or putting these transmitters on birds in different areas. And so that's something that we really hope to address in the future. We can see Great Salt Lake is still being heavily utilized from birds in California. They're making that movement, but we really want to put transmitters on ducks and geese in the Great Salt Lake over the course of winter so we can better understand the habitat connectivity that we have between these other core landscapes and of course breeding grounds as well. And with that comes a better understanding of how these birds would be using different landscapes in the Salt Lake itself. How heavily are they using unmanaged areas versus managed areas? And once we get a better sense of that, we can start answering other questions with habitat covariates and all sorts of different actions there. And that's really critical to Ducks Unlimited and our Great Salt Lake initiative. Some of the work that we've been working on in the past couple of years has been talked about previously, but our idea really here is to use science to really focus on wetland management improvements. A lot of the infrastructure that has been allowing managers to manipulate water and manipulate vegetation on the landscape has been degraded, and so we're hoping to improve that. We also want to look for water quality improvements as well as different water sources come from urban areas. And we're really trying to just generally look for multi-species benefit opportunities. We know how to manage these wetlands given the resources for waterfowl, but how else can we manage other species? So, thank you. I got a few minutes if you have any questions.
Good morning, thank you. I love those maps. My grandpa's a rancher in Idaho who's done some of this work, and I think it's really important. I'm curious to know if Ducks Unlimited is having a seat at the table with some of the discussions of proposed industrial developments on wetlands in Utah. Specifically, I'm thinking of the proposed Utah Inland Port Authority project area in Weaver County, and if so, how those conversations are going.
I'll look at my colleagues over here dodging me. I don't know. I've only been at Ducks Unlimited for a little while now, and I've mostly been on the science side. So I think we should be if we're not involved already. But we do have staff limitations, so I don't want to overextend folks. So sorry, I don't have a better answer for you.
Question and a comment. Ducks Unlimited, I know been involved with Ducks Unlimited for a lot of years. I'm currently a member as well, so let me sure I'm not biased or anything to say. But I think from the standpoint of using the outdoors like I do, I really appreciate Ducks Unlimited coming to Utah, especially the work you're doing in Ogden Bay. I wasn't here yesterday, I didn't mention, but could you touch briefly as to what's been going on in Ogden Bay and reinforcing the claims I can understand it there? What the benefits you're going to see from that?
Yeah, I'll have our biologist answer that question because she's directly involved in that. So, Karina.
Could you repeat the question, please?
He asked what type of work we're involved in at Ogden Bay Waterfowl Management Area. So we did have a NACA grant, which is North American Wetlands Conservation Act, to repair a large levee at Ogden Bay that happened last year. And then we recently received additional funding from the Great Salt Lake Watershed Enhancement Trust to repair an additional levee at Ogden Bay, as well as restore a managed wetland impoundment there.
Thankfully, I have a good team to back me up on questions I don't have the information on. But thank you.
Good morning, everybody. Thank you for having me here today in this edition of the Great Salt Lake Issues Forums. It's always very inspiring to be here and learn from all of you. My name is Marcela. I came from Argentina. I'm visiting here with Pedro, a college student. And I'm going to present very briefly about the situation of some updates about Wilson's Phalarope, more like at a hemispheric level. Very briefly, I wanted to mention that I work for the Western Hemisphere Shorebird Reserve Network, and our mission is to preserve important shorebird habitat across the Western Hemisphere. And we do that, we have a lot of sites, Great Salt Lake is one of the sites, and we do that by supporting our partners on the ground in different areas. And I wanted to make a point in linking sites and partners, because that is, we are working to try to make the network work as a network. And that's a big part of my role, and I'm very focused on saline lakes. Why focus on saline lakes? I'm not going to stop very much here because we have heard about this a lot during these days, but saline lakes are struggling around the world in the Western Hemisphere, not only here in North America. So many drivers of the situation of the lakes are water diversion, climate change, pollution, human disturbances, overexploitation of resources. So everything that happens here happens in other places in the hemisphere. And from a perspective of birds, why are saline lakes so important? And we already also hear about that. And basically it's because saline lakes are kind of like an all-you-can-eat buffet for birds. And they are providing this incredible amount of food resources, but not only the amount, it's also the timing. because many of these birds need these resources prior to migration. So having that is really important for them for the life cycle. If you think about what are the big 5 saline lake species that we can associate with saline lakes in North America, I guess that we can all think about these species like Grebes, California gulls, American avocets, and of course the 2 species of Phalaropes. But if we switch a little the perspective and we think about these from a South American perspective, we will find a kind of different species, the 3 flamingos species that we have down there. And also we have a very cute Andean avocet, but here again is a Phalarope, Wilson's Phalarope. And my point with this is that we are connected by Phalaropes, Wilson's Phalaropes. So this is a hemispheric link that we have between our saline lakes. And I think that is okay to say, I mean, it's a truth to say that the fate of Wilson's Phalaropes is tied to our saline lakes. So understanding what is happening with Wilson's Phalarope across the hemisphere and with Phalaropes, but specifically with Wilson's Phalarope across the hemisphere will help us to understand habitat conditions, and there are like very good indicators of the status of our wetlands in a hemispheric level. So some of the questions that we are trying to address as a group, I need to say that I'm going to present information that is collected by an amazing group of people working across the hemisphere. So this is a very active group of people working, a lot of partners, amazing partners. So we are trying to understand population trends, if the habitat use is changing, how the Phalaropes are what is the Phalarope response to habitat change in habitats, and if we can detect the responses to habitat loss here and elsewhere. So understanding Phalaropes will help us understanding saline lakes and vice versa. So I wanted to share very briefly some of the latest efforts across the hemisphere, and I'm going to start from South America. Very briefly, this was the first Wilson's Phalarope simultaneous survey that we were able to make in February 2020. And this was a major effort when we were able to survey over 700 sites in 4 countries in a 10-day window time. And that includes a lot of lowland wetlands, but also wetlands in the high Andean region. And the main thing that I wanted to share with you is from this survey, we get with a new estimate for the global population of Wilson's Phalarope that is about 1 million birds. And this estimate is 500,000 lower than the previous one. And even though we cannot compare directly the 2 estimates because they are like made differently, and I think this is a number that we need to keep in mind. And the good news is, like just a couple of days ago, we got a confirmation that we are going to be able to do a new edition in next February of this survey, so we will be able to compare new data. Another thing that we are doing in South America, and the main wintering ground for Phalaropes, is aerial surveys at Laguna Chiquita. Laguna Chiquita is kind of like this Great Salt Lake of South America. We are very similar in size. We host very similar numbers of Wilson's Phalarope every summer, every austral summer. And we do the same thing that people do here, like our partners John are doing here. Aerial surveys over the lake is the only way to estimate the big numbers that we have. And this is a very raw data that we have from the surveys that we are doing during the last years, from 2020 to 2024. We are trying to do at least one monthly aerial survey for the lake to have numbers of Phalaropes. And we are still not seeing any very clear trend. There is some seasons that we couldn't make all the surveys, but we are also gathering information about the distribution of the birds in the lake. So we wanted to then combine that information with water level, salinity, and other variables to understand what are the drivers behind the habitat use, and use that information for management in the area. And now I'm going to come back here to North America, and I'm going to share some efforts that many partners are doing here. But basically, this is the North American coordinated Phalarope surveys at the western lakes at the western North America. So these surveys are coordinated, are being done in 6 major staging sites for Phalaropes actually, between 2019 and 2023. The objectives are to create an annual index of Phalarope numbers at major staging sites to evaluate population trends and habitat use, and also to understand Phalarope response to habitat change in the same index. The 6 major staging sites that are part of the survey are Chaplin Lakes in Canada, and then in the US, Lake Ebert, Great Salt Lake, Mono Lake, San Francisco Bay, and Owens Lake. In each of these sites, we have partners working on the ground and actually collecting the information and doing the work. And Oikonos and Ryan Carr is coordinating all these efforts. Basically, the design for the surveys is the surveys are being done between late June and mid-September. So 6 weeks are like defined or agreed to conduct the surveys like simultaneously in every site. So during these window times, these 6 window times, everybody's going to have at least one count. The methodology for each site is standardized, so we can compare the data for each site with very good, but we have to keep in mind that between sites there is a variability in how the surveys are being done. They are related with the site characteristics and resources and things like that. So, but we have at least six counts between late June and mid-September for 6 sites. Another thing that I want to mention here, that this is a big challenge that the partners have here in North America that we don't have in South America. Here there are two species of Phalaropes, rednecks on the top and Wilson's Phalaropes below. And as you can see, they look like very similar in non-breeding plumage. And this is a picture from John Neal, another picture from a flock of Phalaropes in Great Salt Lake. And I just wanted to share this to see first how hard it is to know how many how Phalaropes are. And the second thing is, imagine if you need to identify how many rednecks and how many Wilsons. So the work that they are doing is amazing. And for every site, this happens at every site here in North America. So for each count, we can have up to 3 data set. Amount of redneck Phalaropes, amount of Wilson's Phalarope, and we can have also unidentified Phalaropes we cannot assign to a species. So that is a challenge, because how we can process that information when we want to know the trends for the population for the species. So for the purpose of this report, we are going with this data processing. I mean, we are interpreting the data in this way. Wilson's Phalaropes tends to arrive earlier to the staging sites and depart earlier than redneck Phalaropes. So based on that behavior, the group decided to assign all the unidentified birds at the beginning of the season as Wilsons. And at the end of the season, only the birds that are actually identified as Wilsons are counted like that. On the contrary, at the beginning of the season, only the birds that are actually identified as rednecks are counted as rednecks, but at the end of the season, we are more confident that all the unidentified birds could be rednecks, so they are assigned to that species. But as you can see here, there is another challenge. We have one window time, at least, when the unidentified Phalaropes could be either Wilsons or rednecks. So what are we going to do here is to present the 2 options, like if all those unidentified were Wilsons or if all were rednecks. And we know that that is not possible at the same time. It's just a way to show the results. So this is the big single window count for Wilson's Phalarope across the 6 sites between 2019 and 2023. And the peak annual region-wide is defined as the highest count for the Wilson's Phalarope in this case for a single window count. And we can see the highest count is in 2019, and then the numbers kind of drop. And here we have this situation because in 2023 we have a very high count of unidentified Phalaropes in this window time that we don't know which species is at Great Salt Lake. So we are presenting 2 alternatives. The yellow one is if all those birds were Wilsons, the number will be higher than 2019. But the second alternative, we are presenting the second highest count for Wilson's Phalarope during the season. And this second highest count falls in a window when we are more confident that all birds could be Wilsons. So in that case, the trend will be like going down. And if we break down that per site, we can see, like, the main thing that we can see here is the Great Salt Lake is very important for phalaropes. A lot of phalaropes are being found here. And here, again, we have like the two different scenarios. This one is all the birds were unidentified were not Wilsons, and here is if they were Wilsons. But again, we don't know, so it's just a way to show the data. And here is the moment when Great Salt Lake reached the historic low level. And if we wanted to see the trends for the other sites more clearly, we remove Great Salt Lake from the graphic, and we will see this. And some of the things that we can start to see in this information is some relationship between phalarope numbers and some changes in the habitat. For example, numbers here for Lake Eber were dropping, and here Lake Eber was dry. But then we see that there are increase in the numbers for Lake Eber and Owens Lake, and that is when a big winter provided a lot of water and the lakes were with water again. So there is relationships between habitat use and habitat conditions and phalarope numbers. These are the results. It's the same graphic, but for redneck phalaropes. So again, we have the same situation. We have this big single window count across 6 sites. So this is a region-wide maximum count. And it's pretty much very similar to the Wilson's phalarope graphic. So the highest counts were in 2019, and then the numbers kind of dropped. But then again, here the situation with the unidentified birds, and this would be if all the birds were rednecks, and if all the birds were and this is the second highest count for rednecks. We are more confident that all birds in that window time, the unidentified birds, could be assigned to rednecks. So one thing that I want to mention is that we know that it's very likely that these unidentified birds are probably like a combination of the 2 species, but we don't know. And I know that this is a debate that all the group in North America is having, how to have an index or how to know and improve that related to the unidentified birds. I'm going to skip this, and I'm going to go to, I think this is a very cool graphic. It's very simple, it's raw data, but if we put in this graphic Chiquita data for the last years, and the North American sites combined, including the high count for 2023 as Wilson's phalaropes, we will see that the trend is very similar. So I think that is very cool to see that we are using different methodologies. We are far away, but we are getting like kind of the same trend. So we need to keep gathering information, but this is very interesting. Related with some thoughts related to the surveys, we don't have historical data for redneck phalaropes to compare with, but we do have one count for Wilson's phalarope in 1986. And that can be compared with the data that we have now, and numbers are declining. No matter, it doesn't matter if we consider are the 2 scenarios, like all the unidentified Wilsons or not. And no matter what, the numbers will be declining if we compare with the 1980s. We can start to see evident responses to changes in habitat, and also something very important is Great Salt Lake keeps is continued to be the most important site in North America for phalaropes. So I wanted to change that sentence and said that the fate of Wilson's phalarope is tied to Great Salt Lake. Great Salt Lake has host up to 60% of the world global population and 80% of the adults as one, so it's a very big proportion. And although it rose some because the large snowpack in 2022, 2023, we know that we are still need to do, like, doesn't mean that we are okay and we can relax. We need to keep working to improve the conservation of the lake, and not only Great Salt Lake, all saline lakes, again, across the hemisphere. So what can we do? We we need to keep working locally because we can make differences in our sites, but we need to keep in mind that we are all connected and we are part of this international network. So we can use that network to improve our work, to learn from each other, to support each other. So I think that we need to keep that in mind, that we are a group and we are connected by the Phalaropes. We can use the Phalarope story to tell the story of the saline lakes, and we need to get the big players involved, like local, state and federal governments and all over the hemisphere. We need to keep doing monitoring and research. We need to collect more data, and we need to use that information to inform the protection and the management of the sites. I really wanted to mention, related to that, the presentation of the Wilson's Phalarope U.S. Endangered Species Petition that was submitted in March, where the Phalaropes proposed as threatened designation. This proposal was led by the Center of Biological Diversity and supported by a lot of partners. And basically, threatened is defined by ESA as any species that is likely to become an endangered species within the foreseeable future throughout all or a significant portion of its range. So the petitioners are thinking that Phalarope applies because all the things that we were discussing during this past couple of days. And I wanted to share other ongoing projects and efforts that we are doing across the hemisphere. Again, this is a group of people that are doing an amazing job with saline lakes and Phalaropes across the hemisphere. So some of the things that we are doing too is, like, we presented, recently released the new updated version of the Wilson's Phalarope Conservation Plan. It's free to download if you want to check it out, it's online. We also are working to strengthen the International Phalarope Working Group. We had a very productive meeting last February in Chiquita. It's a very motivated group, and a lot of things came up, so we need to keep following up, and a lot of opportunities there for collaboration. There is also an ongoing project to tracking Phalarope movements across the Western Hemisphere. We are working with partners from Environment Canada and universities in Canada, here in the US, and all the way down to Argentina, to set up Motus towers and to put some transmitters in Phalaropes to understand migratory movements and migratory connectivity. That will help us to understand better Phalarope ecology, but also I think they will improve our message that we are all connected. We can actually show, like, the same bird is visiting the sites that we are living. And other projects that we have, the surveys in North America are planning to be continued. These coordinated surveys to try to have not only a site situation or site data, but regional information. And we are also, like I mentioned before, we are also going to do a second simultaneous survey in the lowlands and in the high Andean wetlands that is covering almost the entire wintering range for the species, and that is going to happen next February. So we need volunteers if anybody wants to join us. And we are also working a lot in education and community engagement, because we think that we need to inspire the new generations of students and to become young leaders in their communities and to do whatever they feel that they want to do, like research, working in government or in agencies. So, but wherever they feel that they wanted to contribute to the conservation of these sites. And related to that, I wanted to mention that we are here with Pedro Costa. He's one of the student of one educational program that we have, that is Experiencia Ambientalia. It's a poster of, related to that if you want to check it out. And we are putting a lot of effort in trying to do some exchanges between high school students and university students. I think that experiences are life-changing and can be really inspiring, and we need more capacity, at least in South America. We need more capacity and people working in shorebirds and saline lakes. So we are putting a lot of effort on that. Finally, I wanted to say thank you to Ryan Carr because he helped me with this presentation, and he is coordinating the surveys and doing all the reporting and everything. A really big thanks to all the partners that are doing the surveys here and in South America, all the people who is working in analyzing the data, reporting, and everything. Thank you to the International Phalarope Working Group members, because they are working to conserve phalaropes and sea lakes across the hemisphere. To the organizer of these events for having me here and giving me the space to talk about Wilson's phalaropes. I just wanted to mention and acknowledge our partners and funders for the coordinated North American survey sites, and also for the coordinated South American surveys. And I will be around if anybody would have a question. And these are my emails if you have a question, or Ryan's email if you have a specific question too. So thank you. Okay, thanks.
Could you say a little bit about the efforts, what conservation or protection efforts are underway in Argentina for Mar Chiquita?
Yes, thank you for asking. We recently, not recently, but almost 2 years ago, we got a designation as a national park. So Mar Chiquita now is protected under a national park designation. That is our highest category of protection that we can have in Argentina. And actually we have like different categories of protection because it's a really big wetland, but a huge part is now under National Park Administration. So we are working together with those agencies, trying to provide all the data that we can to inform the management plans, because they are developing the management plan for the area. So we're very happy. That was a really huge achievement for many organizations working there.
Hello, thank you for being here for your work. I'm curious, for people who want to be involved in this survey, is it best to email you, or is there an online sign up, or how do we go about that?
Yeah, no, we don't have an online setup or form yet, but please email me. We can talk. Yeah.
Yes. One of my hats that I wear is a behavioral ecologist, and I'll have to agree, we do have a lot of rednecks here in Utah. But my question is about the Wilson Phalarope. Here in northern hemisphere, they swim around clockwise.
I'm sorry.
Eating this microphone. Here in the northern hemisphere, the Wilson Phalarope swim around in a clockwise direction. In the southern hemisphere, do they swim counterclockwise?
I'm really sad to say that no. Apparently that is related to each individual and not to the hemisphere. Yeah.
Hi, great presentation. It might be a dumb question and maybe I missed something, but why all of a sudden in 2023 was it apparently so hard to tell the redneck phalaropes apart from the Wilsons in that survey? Like what happened that year?
I think that maybe we can ask that to the surveyors that we have here. And maybe we can help us with that. It's really hard to identify them, but I don't know exactly what happened in 2023. I take this moment to say that John Neal and John Love, we had the fortune to have them down there in Mar Chiquita in last February. So we are discussing a lot how to improve our methodologies and learn from the area services they are doing here down there in Mar Chiquita. So thank you.
So we had a lot of unidentified phalaropes during that survey because we had sometimes they flock up in really large groups, and in that case we can't really identify all the birds in those groups. So that's kind of what happened in this case. And also it was more, I think it was the period after the time when we usually see the Wilson's phalaropes in highest abundance at Great Salt Lake, so the end of July and August is typically the time that we see those birds. Wilson's fowl is most abundant, and we saw it 2 weeks after that. So we were a little undecided on what we should call those birds.
I think that we are out of questions. Thank you.
Good morning, everybody. I want to first thank Lynn for inviting me. Thanks very much, Lynn. Is that okay? Okay, there we go. Despite the invite, I really shouldn't be here. The reason is I'm not a grebologist. I study Arctic geese and sea ducks primarily, but I did get involved with this beautiful bird called the wood grebe in a small breeding area for Barrow's goldeneye up in British Columbia when we were working with some students who were doing their master's degree on eared grebes, looking at the breeding ecology. So we went out, we were catching birds and tagging them with nasal tags on this breeding ground up at Risky Creek. It's called Risky Creek, not Whiskey Creek, although we did drink a little bit of whiskey there. Anyway, it's a beautiful bird, and the title of my talk has changed a little bit. I'm really going to be looking at numbers and distribution, or migration and connectivity, that sort of thing. That's what I'll be talking about today. Risky Creek, way up here in British Columbia, and you got your lake down here, and then Mono Lake. And at the time, I was actually, let me see. So this is what the study area looks like. It's a whole bunch of these small pothole ponds with fringing marshes around the edge, and every one of them, or almost every one of them, has some eared grebes nesting from 2 to 3 birds in a colony to 200 to 300 on a lake. And so I became really interested when we were marking these birds to try to figure out where are these birds going to migrate, where are they wintering and molting. And at the time, okay, here's how we catch the birds. We round them up in these little kayaks. I have to go back here. So there's a grebe right here that we're trying to catch. And usually we're trying to catch maybe 5 or 10 birds at a time. But this is Andre Barreau. Some of you might know him. He retired a few years ago, but he developed this technique using gill nets. So fishing gill nets in the lake. And we end up pushing the birds around and grabbing them out of the net. So it's actually a pretty neat little technique, very easy to catch the birds, especially on small ponds. It's very easy. I was at the same time reading some of the work by Joe Gell at Mono Lake, and he was estimating up to 750,000 eared grebes on the lake. He would boat around on the lake, for 4 days and come up with an estimate of about 750,000. I think he did this about 3 or 4 years in a row. I was also reading this book by John Hart, Storm Over Mono. Some of you probably read that, and Jeff McCulkin talked a little bit about that yesterday and has over the past. But it's all about Los Angeles siphoning off the fresh water going into Mono Lake, starting in 1940 and dropping the lake level by 45 feet in about 40 years. That's pretty significant, increasing salinity. And there was this big court case between the Mono Lake Committee, Audubon, and some other environmentalist types against Los Angeles back in, and they won a court case to raise the water level. But at the time, when I was working on these birds with these students, the number of birds at Mono Lake and the fact that the lake was threatened was really interesting to me. And I wondered how many of our birds actually go to Mono Lake and how many go to Great Salt Lake, so especially the Mono Lake part. So we caught the birds easy to catch, like I said, and we tracked them with these tiny VHF transmitters. Now, in 1995, so this is almost 30 years ago, I tried 3, 4, 5 different techniques to mark these birds with VHFs. Nothing worked. If you stick anything on the outside of these birds, they tear them off within a few days or a few weeks. They just don't like. I thought because they like to carry their young on their backs for a couple of weeks while they're young, that they wouldn't mind having a small transmitter on their, between the scapulars, but they don't. They hate it. And they pull these things off. And in the meantime, while they're trying to preen these small transmitters off their bodies, they are being attacked by eagles and owls and hawks and predated. So it's not a good scene. So in 1996, I tried this technique here with a VHF transmitter. It's about the size of your thumb. And this red part here, these are the antenna coiled inside. So everything's inside the transmitter, and everything in the transmitter is then inserted in the bird by a vet. This is Dr. Malcolm McCady. He's an experienced vet. He has worked with me for 30 years implanting so many different bird species with different, mostly satellite transmitters. Isoflurane, and the bird is out for about a half an hour after the surgery. Put him on oxygen, and the bird just perks up and goes right back to the lake, no problem at all. So it was a nice little technique that worked. So we use that to track these birds down to Mono Lake and some on Great Salt Lake. I flew down to Mono Lake and in the fall of 1997, did a lot of flying around. When you have 2 million eared grebes on the lake and they're all packed into that lake, and you fly around enough with your radio receiver, you're going to pick up pretty well every bird that's on the lake, which I did. I also flew Great Salt Lake, and my first experience on Great Salt Lake was with Don Paul, flying in a survey when we were doing some estimates, so that was really interesting. While I was flying over the lake, okay, these are the results, first of all. These are the results for 1996. And you can see the 50 to 60% of the birds from this little breeding area up in British Columbia, which is on the northwest corner of the entire breeding range of eared grebes. 50 to 60% of the birds that we marked, and I think we marked 25 birds that year, were on Mono Lake, and only 10 to 20% on Great Salt Lake. And I think that's probably an underestimate simply because of the size of the lake and the number of birds. And we didn't do the intensive surveys, or as intense surveys on Great Salt Lake as we did at Mono Lake. But still, most of the birds were on Mono Lake that particular year. Now, when I was flying over the lake, I don't know if you can see this very well, but all of these little dots that you see here, each one of those is an eared grebe. You can see phalarope flying around too in flocks, but these are eared grebes. And so I thought, when I was flying around at about 1,000 feet above the lake level, I figured this would be a really good way to count the birds by doing a photo count. So I did a photo protocol by flying 16 transects back and forth across the lake at 1,200 feet above the lake level. The reason I did that is because if you fly anything below 700 feet, the grebes know or figure that it's a predator, and they will actually dive in front of the airplane. So we fly at 1,200 feet. 16 transects. We take a photo, a vertical photo, stick the camera out the window of the aircraft, take a photo every 10 seconds, end up with about 500 photos over the lake. We also had a scale at the side of the lake where we could estimate the size and the area of each photo. And when you extrapolate it and do the analysis, it comes up with a total count plus and a standard error of 5 to 10%. So it's a pretty good count. Now, one of the things we figured we'd try to do is use this count from one year to the next. Incidentally, this count has been used since 1997 to the present time, and it's being used and has been used here in Great Salt Lake. A little bit of a modification because of the size of the lake and the number of birds. We tried to figure out, should we actually monitor the birds just one time, say in middle of October, to track the trends of the eared grebes. So we figured, the the birds are moving through to the lake from the breeding grounds in August. They build up to a stable number of birds, and then if we actually come back and monitor the birds in mid-October every year, it should give us a pretty good idea of how we can track that population on Mono Lake from one year to the next. But what we ended up finding was quite a mess of information. So we had some counts here. These are high counts. In 1996, 97, you can add 20 to 30% onto that. Those are the birds that would have been underwater when the photographs were being taken. So we did some dive pause analysis, and we know that. But this year here, we know that year was one of the largest ENSO events in recorded history here in North America. And we also know that 50% decline here also happened at Great Salt Lake. And we know that a lot of birds died at the Sea of Cortez that year, that winter between 1996 and 97. Tens of thousands of carcasses apparently washed up on shore. This was documented by some fish and wildlife biologists working in that region. But the other ones here, we don't know what was happening here. This just didn't seem right to me, based on average survival and recruitment rates, that these numbers are a little bit wonky. And so to get around that, we decided what we're going to do is do some multiple surveys to figure out, does this abundance curve, is that assumed abundance curve, does it happen every year? Is that something we could depend on? So we decided to do this starting in 2013. We were only going to do it for 2 or 3 years, but we ended up, we're still doing it, and I'll show you why. So these are the results. You can see, okay, it's a little bit of a mess. We did not do a survey, and actually we did one survey, we did one survey in 2020. I'm not going to show that, but the number is right up in here. And 2023, the numbers have not been checked thoroughly yet, so we're not going to present that. But what I'm going to do is go through each one of these years, year by year, because it actually does show a pretty interesting trend. So this is the first year, and this is the year you can see a million birds were estimated on Mono Lake in mid-September. And then we ended up building up to a peak in October, which is what we expected would happen, the assumed abundance curve that I talked about earlier. However, in the next year and the next year, there were two completely different patterns happening, obviously. So a million birds showed up here in 2014, 800,000 in 2015. I should say, you have to remember that the standard errors around each one of these, again, is only 5 to 10%. So each one of these dots that you see is actually pretty good. So there's not a lot of variation, not a lot of error around these. So we have these patterns here where the birds arrived on the lake in huge numbers and then disappeared very quickly. We didn't expect that to happen. And therefore, we were going to do it for 2 or 3 years. So therefore, we ended up doing it for a number of years after that, right up to the present time. So what happened after that? We decided we would do some surveys a little bit earlier because we thought, well, maybe we're missing something in here. So we started in mid-August of 2016, and you can see we got sort of an assumed abundance curve there with a peak around mid-October. And the next 3 years were very similar, very low counts. 17, 18, and 19. So this is really interesting. Why 4 years in a row, almost 2/3 of the birds that were there in 2014 and 15 that arrived there, they disappeared from the lake completely. We don't know what happened to them. All right, this was 2021. The population is building up and the assumed abundance curve occurred again, and this is 2022. So things are moving back to where we expected them to happen. Now this difference between 21 and 22, that's pretty huge. And it may not be accounted for by natural or average survival rates and recruitment rates. So it's possible that some birds moved in from Great Salt Lake into Mono Lake in the intervening year. Some of the birds that we marked at Risky Creek up in British Columbia on the same small colony, you could have a pair of birds on one nest, and 2 or 3 feet away, a pair of birds on another nest. And if we tag birds from each one of those pairs, one of those birds went to Mono Lake, the other bird went to Great Salt Lake, from the same small pond and from the same tiny colony. It's pretty interesting. So they talk to each other. They know each other. And we think that the birds, some of these birds are individuals that are actually familiar with both lakes. How they do that, I don't know, but it seems like that's what's happening. So I'm going to go over and talk a little bit about the first 3 years of the surveys and what happened between here, the high abundance, assumed abundance curve that we have, and this disappearance here. So why did these birds leave the lake? In fact, you know, they would have been molting right at this time normally, so they molt through this period. It takes them 2 to 3 months to do their full molt. They're molting all of their body feathers and their flight feathers and replacing them with new ones, okay? That's why one of the purposes of these birds being on these lakes in the first place. So why did they depart the lake so quickly and didn't molt? And we think it has to do with this. The brine shrimp densities were the lowest ever recorded on Mono Lake in those 2 years. These are the September numbers, densities. It's in numbers per square meter, which is kind of a strange unit for me. But Joe Gell has done a lot of work on the Grebes and Mono Lake, and he figures that about 5,000 is a critical threshold for these birds, below which they will not molt, they will not build body reserve, they won't molt, and they'll leave the lake early. So that kind of explains what happened in these 2 years. At least we think that's what happens. It's correlative, but pretty high inference, that's what's happening. And then what happened to the next 4 years where the numbers of birds that, you know, we had 1 million to 800 to 1 million birds in the lake here. What happened over here? We lost, the large majority of those birds did not return. Did they all die? They didn't die on the lake, because we know that. There were surveys that were done, and there were not tens of thousands or hundreds of thousands of carcasses washing up. It could have happened in the Sea of Cortez, because it did happen in 97, between 97 and 96 and 97. Or it could be that those birds moved to Great Salt Lake in the intervening year. That's my suspicion. It's unfortunate we didn't have radios tracking these birds. It would have been ideal, and we would know exactly what happened, but we didn't have that at the time. So we went back in 2017, so 22 years later, marked birds, not the same birds obviously, but birds on the same ponds with the same transmitter. And we also tagged them with these geolocators, light level geolocators, so I get an idea of migration patterns and wintering areas, okay? We marked a lot of birds, but what happened in 2017 was that there was a huge fire. Half of British Columbia burnt up that year, including the study area. We weren't allowed back in. We couldn't do a lot of captures of birds that year. And the next year, a couple of years after that, COVID started, we weren't allowed in the field. So unfortunately, a lot of the geolocators, we only, I think, recaptured maybe 15 out of the 60 birds that we tagged. Okay, so remember that in 1996, most of the birds from British Columbia went to Mono Lake, 50 to 60%. The next year, the complete opposite happened. 50 to 60%, not the next year, in 2017. 50 to 60% of those birds went to Great Salt Lake, went here, and only 10 to 20% to Mono Lake. So the question is, did that happen gradually in those 22 years, or did it happen suddenly in the 2016, 15, 16, when we lost a lot of those birds from Mono Lake? We don't know. Again, this year, between 1996 and 97, sorry, 97 and 98, when we lost about 50% of the birds on Mono Lake, and the same thing happened in Great Salt Lake. We know that there was a huge die-off of birds in the Gulf of California. The next very strong ENSO event was in 2015 and 16, and we don't know We don't have any information on mortalities in the Sea of Cortez then, but it's possible. I don't know if anybody was working there at the time. My suspicion, though, is that the birds in those years moved over to Great Salt Lake because, like I said earlier, they are aware of both of those lakes, at least the adults. I want to talk about, just very briefly, a couple of potential projects that will benefit our understanding of eared grebe ecology, numbers, and migration and distribution patterns. The first one is using thermal imagery and automatic counting techniques. Now, this is a project that we worked on recently in British Columbia using a drone. This is the drone that you see in the picture. On herring spawn, so marine birds on herring spawn. The other one is using stable isotopes to match up breeding grounds to molting areas, so Great Salt Lake and Mono Lake. So the drone survey that we did, we just completed about a month and a half ago on the coast of British Columbia. We have some of the biggest herring spawns in North America. And we have 100 to 200,000 marine birds using those spawns in March. And the idea was to use the drone to actually figure out if we can actually use this technique to count the birds and also to speciate, to determine the species ratios. The image on the right, okay, this is the spawn. You can't see this is a terrible photograph, but there's about 10,000 marine birds on the spawn here. But you can see all these little orange blobs here. Each one of those is a bird. The thermal sensor actually is very good at identifying birds with their warmer bodies on cooler waters. So this is something that could be used here at Great Salt Lake and at Mono Lake with an airplane. Can't do it with the drone because the lakes are too big. But flying back and forth over the lake and overlapping these the photos or the videos. And you can come up with a really accurate count of the number of birds. You can also, with an optical sensor tied to that, determine species. Now, on Mono Lake, 99% of the birds are going to be eared grebe, so it's not a problem. You're going to see some gulls, some California gulls, and some Phalaropes, so it's possible that would work with the optical sensor. Now, the other one is stable isotopes. I've been working with a colleague, Dr. Keith Hobson, who's one of the world experts on stable isotopes. He's published a lot. He has brine shrimp samples from Great Salt Lake and from Mono Lake, and you can see here the difference between, I think, hydrogen, carbon, and nitrogen. You can see the error bars are 95% confidence limit, so you can see that they're statistically very different. So the stable isotopes on the brine shrimp from here and Mono Lake are completely different. Those stable isotopes are incorporated into the body feathers and the wings of eared grebes when they're molting on these lakes, okay? They're developing these new feathers. So, and when you do these biplots between the different nitrogen and carbon and so on, they're completely different. So this is really important. What this means is that you can actually go to the breeding grounds. This would be a cool project to do, and if I was starting a PhD and I had some funding, I'd love to do it. But this would be something you could just go to these different breeding grounds and capture eared grebe very easily with this gill net system that we use. Sample their flight feathers, their primaries or secondaries or even tertials, because those feathers stay on those birds the entire, from the molting period all the way through to the next breeding ground period. And then you could link up all of the different breeding ground sites to the two different lakes. You can even determine if some of those birds would be molting on those lakes, and some of those birds might even bypass the Mono Lake and Great Salt Lake, maybe even molt down in the Sea of Cortez. You don't know that. And you'd be able to learn that through these stabilizations. So those are two potential projects, I think, that you probably should look at. Some of them are going to cost some great funding, but certainly be worthwhile understanding the eared grebe ecology in North America. So just a few GLS maps. This is a color wheel. Each one of these numbers here is a different month. You see when you follow the month, the track of this particular bird down to the Sea of Cortez and back up again, You can track it by month and the color. So this bird was marked here at, again, at British Columbia. It staged and molted on Great Salt Lake, went down to Mexico where in the winter, spent the winter, came back up. Looks like possibly even stopped at Salton Sea, I guess, and all the way back up to Whiskey Creek. This bird, oh, I should say, this bird also was carrying a VHF, and that VHF was detected on Great Salt Lake, so that verified or validated this geolocator location information. This bird didn't carry a VHF, just a tag. It molted and staged on Great Salt Lake, down to the Sea of Cortez for the winter, came back, probably stopped here. In fact, you may have some eared grebes stopping off on spring migration right now. Stopping off here at Great Salt Lake, all the way back to Whiskey Creek. This one is really interesting. Molted on Great Salt Lake, but came over to San Francisco and spent the winter in San Francisco, and then came back up again. And then the final one, we had one bird where we have 2 years of information. Whiskey Creek, down to a molted stage on Great Salt Lake, spent the winter in the Gulf of California, came back to Great Salt Lake for a little bit, and then back to Whiskey Creek. The next year, did the same thing, essentially. Kind of overshot Whiskey Creek on the way home, but basically did the same thing. So it showed a huge level of phallopatry, and this was also detected on Great Salt Lake in 2017 in October. So to summarize, connectivity patterns between British Columbia and these two lakes, these two big lakes have changed. We don't know if it was sudden, if it happened sudden or it was gradual. And it probably happened in other parts of the breeding range. Multiple photo counts are needed on Mono Lake and Great Salt Lake if they can be done. Now it's more difficult here because of the size of the lake and the number of birds, but certainly definitely needed at Mono Lake. And if we use thermal imaging with an aircraft, if we get the funding for doing that, that would be awesome. That would not only be more efficient and accurate, you could probably do more surveys with the time that you have. Shrimp densities influence eared grebe abundance patterns at Mono Lake for sure, I showed that. And probably these ENSO events as well, where a lot of birds can die down at the Sea of Cortez. And then we could also use these VHF and GLS tags to reveal the connection between breeding grounds and Mono Lake and Great Salt Lake, like I showed from British Columbia. That could be done across the breeding range, in addition to sampling feathers for stable isotope analysis. I mean, it would be an incredible project, but all of this information would add to our knowledge of eared grebe ecology, numbers, and conservation issues. Okay, thanks. Okay, just want to mention one last thing, is that more than 90% of all North American eared grebes stage and molt on these two lakes. That makes these two lakes for eared grebes, the entire North American population basically, very important to this particular species. It's ranked as a species of least concern by UN, and I really don't understand that. It was probably due to the fact that there's so many birds, millions. However, the fact that this is one species, and how many species of wildlife, let alone birds, would use two postage stamp sites for a good part of their annual cycle, and both of those sites are threatened in some ways, certainly by climate change. I would think that would raise the level of concern for this species to a higher level, to concern or something like that. So I want to thank just the Mono Lake Committee, Robbie DiPialo, and Igor Vorborov, who is doing all the counting, and some pilots, and Lighthawk Conservation Flying. Last thing I want to say is this work at Mono Lake is being done by the Mono Lake Committee and NGO, on a shoestring budget with volunteers as well. That should not be the case. It shouldn't have to take a Canadian to go down there working with an NGO to work. And my managers gave me grief the last few years. Why are you working on these birds in California? Why are the Americans not doing it? And I said, well, my argument was a lot of those birds on those two lakes nest in Canada, so it's our responsibility. We have to understand that. And also, nobody else is doing it, so there should be some level of support from some federal government agency in the US or California state to support the monitoring of eared grebes at Mono Lake. So I'll end there. Thanks.
All right, thank you guys so much for having me here today, especially thanks to Lynn for inviting me back at the chat meeting in December. Yeah, it's really cool to be standing here. I attended this conference back in 2022 just as a technician of the Great Salt Lake Ecosystem Program. You know, seeing the lake in its dire condition really inspired me to want to go back to school and take on lake issues. So there's a lot of really great and inspirational faces in this room that I really admire. So. Yeah, I'm here today to present on my proposed PhD research at Utah State University under the direction of Mike Conover, looking at waterbird bioenergetics of impounded and non-impounded sheet flow Great Salt Lake wetlands. This work was largely sponsored in part by the Great Salt Lake Basin Integrated Plan to start to understand how wetland resources are influencing you know, the way that birds are accessing foraging resources on the lake. So we've seen this graph a lot, or these pictures a lot, we've beaten them to death, but as we know, we've seen drastic declines in water level in the Great Salt Lake over the past 40, 50 years, seeing historic lows in 2021 and 2022. And specifically, I want to draw your attention to, you know, where we're seeing the most dramatic losses in these surface water areas, which is going to be on the eastern side of the shoreline, which is primarily where all of our wetlands are. And so this has prompted a lot of questions in the past couple of years about how are changing wetland water conditions influencing waterbird foraging resources. So we're seeing these catastrophic losses, and as we know, a lot of our shorebirds and our waterfowl are reliant on these open water areas that are shallowly flooded to forage during their key migratory periods in the spring and the fall. So what role are our wetlands playing in the Great Salt Lake ecosystem? So, you know, we've talked a lot in this conference about the pelagic resources, and we're very familiar with those. They're kind of the poster child for the Great Salt Lake. So these are going to be our brine shrimp and our brine flies. You know, these are critical resources for these millions of migratory birds that are passing through here, and we think a lot about them in terms of our kind of poster child species, like our Wilson's Phalaropes and our eared grebes. But what we don't often think about when we think of the lake is all of these resources that are existing on this eastern shoreline. We've got a much greater diversity of food resources. We've got our corksids, our midges, and then we've also got extensive quantities of seeds and submerged aquatic vegetation. And these areas, kind of like Dan was talking about earlier, we've got both managed areas where we're seeing these resources. We've got waterfowl managers that are doing an awesome job of, you know, perpetuating waterfowl resources and trying to time water delivery so that these birds have enough food when they get here. And then we've also got unmanaged areas that are going to be much more variable in flow, but are seeing a lot of the same types of food resources. And so this comes into play a lot when we start to think about how birds are using these areas. So we've got, you know, our poster child species that are really predominantly feeding in the pelagic region. They're really looking for those brine flies and those brine shrimp. But then we've also got, you know, while avocets and phalaropes and grebes are using these pelagic resources, we're also seeing these birds in our wetlands. And we've got, you know, these hundreds of thousands of ducks that pass through here as well that are also relying heavily on these wetland, or exclusively on these wetland resources. And then, you know, when we think about these birds too, we also think about kind of like shape and size and how they're using the landscape. So we've got, you know, our grebes and our phalaropes that kind of have this capacity to, you know, float around and forage in the sort of shallow or even the deeper water areas to get at these pelagic resources. But then we've also got, you know, depth constraints within our ducks and our shorebirds as well. So with our avocets and a lot of our representative shorebird species, they're not going to be foraging in water that's under 25 or over 25 centimeters. And then dabblers are going to be kind of in that, you know, 50 centimeter and under range. And then we've got divers like our buffleheads that can forage up to like 1.5 meters or like 5 meters. So just because we have these resources available, the way that depth is influencing how these birds use the landscape is something that's important to consider. So my project is to basically look at sort of how these resources are distributed, what we have out there in our wetlands, and how these resources are distributed along the landscape. So I am working on an observational study to evaluate seasonal drivers and the caloric availability of foraging resources in Great Salt Lake wetlands. This is going to primarily be submerged aquatic vegetation, macroinvertebrates, and seed resources. And I hope to pair this with state census data sets as well as my own bird population density estimates so that we can start to assess how bird population dynamics are playing into this whole availability piece when we're looking at foraging. So we've got a finite amount of calories available in the system, and we want to know how these birds are using these calories. And so one way that we're hoping to do this is by developing kind of a traditional wet bioenergetics model so that we can start to quantify how these resources are interacting with our birds in the system, so how many calories are being used and if there's a deficit. And the hope is to eventually move towards a more predictive waterbird model for water birds that includes both waterfowl and shorebirds so that we can be able to predict how many resources we have available given us particular water level. So my study takes place on 6 different areas. I've got 4 of these impounded and managed wetlands that are along the eastern shoreline that are listed up here. And then I've got 2 unmanaged wetland areas that are going to be Willardsburg and Farmington Bay. Important differences in between these areas are 4 areas listed in red are going to be these impounded and diked wetlands that are going to be able to be manipulated by waterfowl managers to perpetuate different waterfowl foods. There's also a lot of really aggressive invasive species management in these areas, which is awesome as far as conserving habitat. And these are going to look a little bit more similar in terms of composition. And then our 2 unmanaged areas are going to be a little bit more unpredictable because they're going to be much more subject to variable water levels and flows throughout the course of the year. And with that, variability, we also see variation in habitat. We have a lot more emergent vegetation communities and mudflat playa communities as well. So that may hopefully be correlated with a greater diversity of birds that we see in these areas. Other things that we're looking at in this study is we're also interested in how hunting pressure is influencing, especially our managed areas. In the fall, these areas, there's rest units where birds are kind of safe to forage freely and are not open to hunting. And then we've got hunted areas that are going to have kind of intense hunting pressure, and you go out there and you don't really see any birds when the hunters are out there. So we're really interested in sort of looking at how hunting pressure may be driving the availability of foraging resources within these impoundments. And then in our unmanaged areas, which are also open to hunting during the fall, we're seeing a much lower level of hunting throughout because they're much larger, and so hunters are going to be more distributed across the landscape. So we're predicting it may not have as much of an impact. As far as timing, we're trying to catch sort of these peak periods of food availability during spring and fall migration. So we go out and we do food availability work in April, August, and November. These maps up here are showing kind of our quadrants. So we've randomly placed transects within each of these quadrants. So we're uniformly sampling across the landscape. And then at 5 points along each transect, we basically take a water sample, a core sample, and a vegetation drag to collect different waterfowl foods. And when we collect these samples, we're really looking at everything. So we're out there on airboats and we're getting these macroinvertebrates, seeds, and submerged aquatic vegetation, and then taking them back to the lab, freezing them, and spending really extensive time picking through and sorting out anything that could be consumed by a water bird. As you can imagine, this is a really time-intensive process. And we've got, fortunately, we're really fortunate to have NAMS taxonomists on speed dial to help us identify bugs, and I've been working a lot with Karin Kettenrick's lab as far as identifying the aquatic vegetation and seeds that we're seeing. And I'm really excited about this, but we're hoping to, identify foraging resources down to the lowest taxonomic level, take dry weights on these so we can get a rough estimate of biomass, And then the hope is to use generalized linear modeling to look at how some of these abiotic resources are playing with some of our abiotic factors. And our partners at USGS have been really awesome and have been coming out with us to take measurements of turbidity and specific conductivity, so we can look at how salinity is playing a role. And we have temperature and depth measurements as well at each of our sites. So yeah, since we're still processing through these samples, we've been looking a lot at how can we start to sort of get at the answers to some of these questions without having our full biomass estimates yet. So we've been working a little bit on doing some SAB density modeling with kind of an in situ measurement of SAB density that we can take in the field. And this is all very like raw and exploratory data. But this is kind of a cool example of the types of relationships we're looking to investigate. SAB, submerged aquatic vegetation, is a pretty known important waterfowl food. And so looking at how it plays with things like turbidity, which is a measure of water clarity, could be important as far as determining how we can manipulate these managed areas to perpetuate more of these food resources. And the hope is to eventually replace these more visual estimates with these more specific biomass estimates of different waterfowl foods. And another really cool way that we can look at this, and I think this is kind of an interesting subject in terms of how management plays a role across the landscape, is when we start to look at depth. So these are going to be this is just a quick glance at our depth data from our August and November survey period. And as you can see on the far left here, we've got our 2 unmanaged areas, and you can see sort of what we would predict, that we've got more stability in terms of August and November in terms of the depths of water that we're seeing in each of these impoundments. And obviously there's a greater variation of range too, so you're seeing that potential for different birds to utilize different depths for foraging. And then when we add our managed areas into this, we see how management really plays a role. So we've got these significant increases in most of our unmanaged areas where we're seeing this water right transfer between August and September, when the waterfowl managers are basically able to draw up their wetlands in preparation for the hunting season. And so it's really cool to be able to see how how we can manipulate these areas to target different species. And it's important to recognize this is just a snapshot. We're looking at 2 impoundments at each of these WMAs. So this is also how it looks when we actually break this down into our individual impoundments within our areas. And I think it's really interesting to note here, if you look at our rest areas, which are going to be noted kind of along the x-axis down here, 3 out of 4 of our rest areas in the waterfowl management areas are sustaining depths that are really kind of ideal for shorebird foraging. Which is really awesome, especially in August when we're seeing kind of peak periods of shorebird numbers in our lake ecosystem. So yeah, and then we've also got variation in how different managers are drawing up and drawing down impoundments. Ogden Bay you can see the management that was being done at Ogden Bay, where they were doing work on the berm in the rest area, so there was not as much water there. But it was really cool to be out there on the lake and see the shorebirds that are using these areas, and then, how different species are occupying these spaces. So that's some of the work that we've been doing in that aspect. And then we've also been working on evaluating waterbird population metrics. And the primary way that we do this is by doing point counts. So we've been doing monthly distinct sampling during the summer and the fall. So we're kicking that off now, and we'll plan to continue that through about December. And we basically go out to kind of randomly selected points along the dikes at each of our areas, and we try and count as many dikes as we can, and we basically use a pair of range-finding binoculars to count all the birds that we see in a 90-degree wedge. And this is going to include waterfowl and shorebirds. And then we hope to pair this with state census counts so that we can get metrics of overall abundance and use this density information to sort of scale out our density estimates to know how many birds we have and approximately where they are in terms of diversity. As far as project outcomes, we're hoping to pair some of this work with a GIS analysis that sort of looks at where specific depths in the lake might be. So it's really awesome to see some of this new GIS data coming out, updating bathymetry, and being able to pair that with different habitat data sets that we have access to. We're planning to do this over multiple years so we can compare how things are changing both between seasons and between water years that are going to have variable water flows. And the hope is to do a traditional kind of wet model, which I think Dan mentioned briefly in his talk, And then the hope eventually is to continue this research. You know, I'm kind of just the pilot person on this project, but there's a lot of capacity to really like work and manipulate this system and understand it better and move towards things like agent-based models to get a better aspect, a better metric of how individual behavior and movement is playing a role in this system. And yeah, as far as predictions go, I think that hunting pressure is probably going to influence the way that birds are eating down these impoundments. Birds don't like to eat where they're being shot at typically, and so where I think that we're going to see you know, differences in the way that food is being sustained in these systems throughout the fall, specifically in these unmanaged areas. And I think we're going to maybe see a more even drawdown of resources in our unmanaged areas. I also think that as the preliminary data looks at, these birds are going to be limited by water depth, so they're not going to be, just because there's water and food there doesn't necessarily mean that every single species is going to be able to access it. So I'm interested to see how our depth measurements change between seasons and between years, and how that influences our biomass as well. And then also, I think that diversity is going to look really different. You know, these impoundments are managed specifically for waterfowl, which is super important and it's really wonderful. But I think that, you know, given just the variation in water depths that we see between our managed and unmanaged areas, that we'll probably see kind of a greater diversity of species and potentially food resources in our unmanaged areas than we might see in our managed areas, because they're being targeted for these, they're being specifically managed for these super high calorie and really critical resources for waterfowl. So yeah, with that, I just want to thank you guys again for having me here today, and I'd like to acknowledge my funders, the Division of Wildlife Resources, the Division of Water Resources, Delta Waterfowl, Sportsmen for Fish and Wildlife, and the Utah Wetlands Foundation, and also thank USGS, Christine Ramsey with USGS, and our Great Salt Lake Audubon folks for their support in this project. And yeah, just one more shout out to the Great Salt Lake Ecosystem Program. I couldn't do this without y'all's support and your advice. So yeah, if you have any questions, feel free to ask them, or you can reach out to me via my contact information. So, thanks.
Awesome research. Thanks for doing it. Are you going to be able to tease out how impactful carp is to wetlands and the influence it has on food for water birds?
Yeah. So we've been noting carp in our surveys. Specifically, I mean, we're going to quantify anything that gets into our net. And so we may potentially see some like baby carp, but as far as actually assessing their populations and how they're influencing, how they're actually influencing the wetlands, we see their presence, we observe it specifically in turbidity, when we see, you know, because they stir up the water column and that increases our turbidity, especially in August when the impoundments are more shallow. So we may hit it there, but not specifically measuring carp presence.
I just wanted to ask a quick question about water depth.
Mm-hmm.
You showed that it did vary. Do you have any idea of how rapid that change in depth might be? Because as you foreshadowed, accessibility to food resources is going to be really critically based on that.
Mm-hmm. Yeah, so I know that the water rate changes a lot between August and September, and it varies by impoundment as to when those, when basically the managers have the access to draw that water up. And so, yeah, it's a relatively quick process, I believe, once it starts, but there is some variation, and they typically wait to start that until about September.
Thank you so much for the presentation. I recently went back to school to do academic research, so you're an inspiration. This is great. I'm curious to know if part of your study will look at potential differences between the quality or caloric density of the food sources between different areas or in different conditions.
Mm-hmm. So we will have density estimates, but all of our water and soil core protocols are evaluated to kind of get at density. So yeah, the hope is to use that in conjunction with some of this water quality data that we're collecting so that we can really kind of nail down what abiotic factors might be playing into the quantifying how many, or basically like how they're driving biomass. Thank you so much.
Okay. Can you guys hear me okay? You'll have to excuse me, I just got back from my psychiatrist, and I was diagnosed with a mild case of pronoia. That's where I think the whole world is conspiring to make me happy. So anyway, a lot of people like to think that the hokey pokey is really what it's about. But I like to postulate, what if the seagull shuffle is really what it's all about? And of course, we all know Farmington Bay is one of the most productive wetlands in the world, and it's pretty much in trouble right now because of all the things going on with it. So we all know this is a problem. But what I'm going to be talking about today, the area that I'm interested in talking about is what I call the stage of the Grand Waltz. The Grand Waltz is all the dances that we're doing since the beginning of time, going through the universe, and you and I are all participants in it. And it took billions and billions of years to get to where we're at. And right now, as we're talking here and visiting with each other over in Farmington Bay, there's this little seagull waltz going on, the seagull shuffle. So what I'm talking about here is the area that I'm talking about is the sheet flow, mud flow wetlands, the areas that are inundated with fresh water and shallow enough for the birds to wade in. And of course, they're spatially and temporally variable. So that's where we're going to be talking about today, where our study is. And so what I'd like to do is introduce the seagull shuffle. It's the pas de deux of the Grand Waltz. They start the Grand Waltz with the pas de deux in the late winter and early spring before the other dancers make it and arrive at Farmington Bay. And so the shuffle is, I'm sure a lot of you folks have been out there on Farmington Bay and wonder just what is going on with these seagulls. They're actually California gulls. I call them seagulls. It sounds better as a seagull shuffle. These are all Lara, so each one of these names is Lara. So if you want to talk to them, this is Lara, there's Lara, there's Lara. So they're all Lara. So they show up, it's part of the Grand Waltz, scientifically known as the mutualistic positive feedback loop, which is pretty cool if you're a scientist or ecologist. And Native Americans would call this the counterclockwise dance. So what you do is you go dance backwards, and you look at the universe from a different perspective. So what we're asking you folks today is to look at the universe in a different perspective from the seagull's point of view. And some people also call it the poo-poo dance. And if you're familiar with poo-poo, this is very important in their shuffle. So we'll be talking about that a little bit too. And the seagulls have been doing this, practicing this for millennia, and they've got it down pretty good in Farmington Bay. So this is what I'm talking about when they shuffle their feet like this. So they have to figure out, why are they doing this? The reason they're doing this is because, not just because it's fun, but they're looking for midge larvae, mostly midge larvae. And as you can see here on the top left, all these are depressions from where the seagulls were doing the shuffle. The picture further to the right is a really good shuffle where they did a really good dance there. And what they found was all these midges down at the bottom here, the red chironomus, and you can see little white colored ones are the tanipus. So that's what they're doing for their shuffle. They're dancing for food. The most midge larvae are the ones we're talking about today. We've got chironomus and tanipus are the most abundant midge larvae in the Farmington Bay wetlands. If you look at the photo there, those are adult midges. These are not brine flies. Some people say, oh, look at all the brine flies. No, these are actually freshwater midges. So try not to get confused with that. So midges are important ecosystem engineers. I could go through this slide maybe later when we have more time to discuss just how incredible the midges are for engineering the ecosystem of the Farmington Bay and these shallow sheet flow wetlands. The mutualistic positive feedback loop is really important, and I was inspired by these guys here, Heron et al. And they were talking about the positive feedback loops between midges and algae. But what happens here is that the wading birds interact with the midge larvae and interact with the benthic algae and the nutrients, and it all works together in a positive feedback loop. And we'll talk a little bit about the power of the midge. Benthic algae uptakes nutrients from the water column, and they use this
these nutrients to grow. And so the algae restricts the nutrients from the sediment from entering the water column. They put a little layer here of benthic algae so nutrients can't go up into the water column as easily as they would if it wasn't there. And they're taking nutrients out of the water column. And the midges are grazing on the benthic algae. And so the more benthic algae you have, the more the midges graze and the bigger the midges get. And the more the algae grows and the more it takes out of the water column. So it's pretty cool stuff. And so this occurs until the midges have interspecific competition from each other or intraspecific competition, or when you get birds that start feeding on them and doing their dance. Now, what we did was do some exclosure cages on Farmington Bay, and you can see this top left is inside the cages and outside the cages. Inside, if you could look really close, you see all these little dots. These are midge larval tubes. So they're pretty much uniform in distribution, and they're showing that it's pretty much density dependence. And outside, they're less uniform, so there's not as much density dependence on there. Bottom left, you can see kind of a three-dimensional view of the midge tubes, and they're sticking out of the water. You can actually see a couple little tanipus sticking their heads out and a couple of chironomous pupating, getting ready to turn into adults. So what is really interesting about this, the midge also have put out nets made out of silk, and so there, you can see on the bottom right corner is where there's more algae growing, and that's a lot of it has to do with the midge nets stabilizing the sediments and actually farming algae. Look, there's more midges inside the green area than there are outside, so that's where you see more midges growing. You're going to see more algae also. But then we get to the pupu intermezzo, and that's where the seagulls and little avocets have a lot to do with, and all the other wading birds. So if you look up at this main picture here, all these little circles where the vegetation is growing and the algae is growing, that's either from where the seagulls did their shuffle, or it's where the avocets or other shorebirds did their little poo-poo in there, and it's fertilizing the habitat. So you can see it down the bottom left too, and in the middle photo too, you can see that pretty well too, that this is where you're getting more algae growing and more midge densities are growing. Bottom right-hand corner, you can also see an upper part of that is when the midge larvae pupate and fly away as adults, they leave their little tubes open, and so the vegetation, the little seed pods from all the vegetation can be fertilized inside those little tubes, so you get some nice little SAB growing as well. So it's all this intricate dance going on between the seagulls and avocets and the midge larvae. So we're going to talk a little bit about our science here, and the midges are going to take center stage in our research. So one of our research projects was that we put out 6 bird exclosure cages in 2020 to 2022 in Farmington Bay, and we did benthic samples using the shovel technique. So it focuses on what's in the benthic sediments of this type of sediment. So we looked at 379 benthic samples and processed those, and we also did our samples out after we took out the cages, so we have a little more data in 2023. And we did bird counts about 2 times per month and maybe 1 time per month. And once again, we focused on the chironomous and the tanipus. And about 95% of the total invertebrate abundance was those 2 taxa. And once again, they're the most important food resource for birds in Farmington Bay, and they're premier ecosystem engineers. And they drive the mutualistic positive feedback loop. So we did all this fancy science that bioenergetics scientists do. We looked at we measured 50 larvae from each sample to the nearest 0.1 centimeter. We estimated the biomass for each size class. We estimated the somatic growth for the midges larvae, and converted the biomass to several other measures. You could use as many different measures as you want, but ecologists like to use joules as equivalent energy. You could use calories, you could use carbon or nitrogen or something like that. But most of the folks working on energetic food web models use joules as the unit of the monetary unit. We also looked at the resting and field metabolic rates and the daily energy intakes of the birds using these formulas. And some of the things that we found, that we estimated the daily energy intake for all the bird species that are the most common out in Farmington Bay. You can see what their daily energy intake could be based on literature values. And we always like to talk about poo-poo in our group. So we're talking about daily excrement rates, grams per day of individual for calcium, nitrogen, and phosphorus. You can see way down there, the California gulls, the seagulls, they poop out about half a gram of phosphorus per day. So that kind of fuels the whole feedback loop. Looking at biomass trends for Chironomus and Tanipus, you can see some trends going on here. One important thing here is there's seasonal trends and there's also annual trends. And one of the cool things that we found is that on a dry weight per gram per square meter, the median value would be about 10 grams per square meter, which is a real lot. That's a lot of biomass being produced in these wetlands. Inside and outside the cages, Chironomus and Tanipus. Inside, there was way more proportional biomass inside the cages than outside, showing that the birds were preying on the midges. Looked at bird predation on the larval size classes, and you can tell from this graph here that inside the cages, the midge larvae were much larger than outside, showing that the birds prefer the larger larvae. They prefer the larger size bright red Chironomus. They're easy to see. Seagulls key in on that large color in the Chironomus. So they're focusing on larger Chironomus, but they'll eat everything they can get on when they need to. Okay, so also you could look at the larval somatic growth of the midges, and it's pretty much temperature dependent, and this is in megajoules per square kilometer per day, and you can see as the temperature increases, the midge somatic growth increases, and they grow much faster. The smaller the midge is, the faster it grows. Looking at one important thing too is in the winter time when all the birds are gone, all the shorebirds and waterfowl are gone, the midges are actually fattening up and getting ready for the grand waltz in the springtime. So you can see from this graph that the midges are actually growing and putting on lots of biomass over the winter months, which is pretty cool. Even at low temperatures, 0 to 2 degrees Celsius, they're still able to grow and put on biomass. And if you look at the energy intake for the shorebirds and the gulls, the monthly energy intake on the right compared to the Chironomus available energy, you can see that they're almost mirror images of each other. In March and April, you can see that the midge biomass starts to decrease while the shorebirds and gulls increase. Same within the summertime. There's a big bottleneck going on in the summertime. You can look a little bit closer at this bottleneck, and you can see that during the months of July through September, there's just barely enough midges to keep the birds alive. Of course, the birds are eating other things, but if we're looking just at midge larval biomass, the birds seem to be hammering the midges really well, and there's not that many midges left when the birds are very abundant. But lo and behold, as part of this big grand waltz, just over the hill in the Great Salt Lake, you have the brine fly adults coming out in that time of year too, so the birds can fly over there and get lots of brine fly biomass as well. So it's all working together in this great big grand waltz. And if you're interested in how many midges larvae each bird requires per day, here's a little chart here. I'm kind of fond of California gulls. So you look like at the bottom there, 46,000 or so midges per day they have to eat. That's a lot of midges if they were just strictly eating midges. But of course they're eating other things, but that's still a lot. But you have to remember that the midge density is 10 to 20,000 per square meter, so it's only just several square meters of midge larvae they have to search for when they do their shell form. So one thing we're looking at is carrying capacity of the birds and other things like that. So you have to remember carrying capacity is determined by prey and the birds and their environmental conditions, and it's the prey density and the biomass is variable The prey growth rates are variable, water temperature, plant growth rates, and all that stuff, minimum prey density. You have to keep, you can't eat all the midges and all the food out there, or there won't be anything left for the next year. You have to look at the relative abundance of the birds, condition of the birds, and all that kind of stuff. You can see on that graph on the right that I think that carrying capacity may be decreasing on Farmington Bay, and that it's highly variable, and it's related to how many birds are out there. So when you're trying to determine carrying capacity, you have to be really be careful when what you say, what is the carrying capacity on Farmington Bay, because it's going to be very variable. So our goals, our goal really isn't to determine carrying capacity. What our goal is to do the best management of the entire ecosystem, and we're developing an ecosystem function model. And you can see our little flow chart of the Farmington Bay food web model up top. And so what we want to do is test different management scenarios, including one that we're focusing on right now, is that our hypothesis is that there's an optimal amount of nutrients that maximize ecosystem function and water bird population variability. So we don't know what that optimum level of nutrients is, but it's somewhere like along this continuum here, and it's not necessarily population and viability of the birds is not always going to be overlapping the ecosystem function. So we have to balance those things as well as we can for whatever goals we want to achieve. And in conclusion, dedicating this presentation to the state bird, the California goals, wherever they may wander. So if you have any questions, we'd be glad to answer those.
Great job, thank you. Were any of the places where you put your cages areas that have been cleared of Phragmites? I know that Karen had mentioned at one point, or somebody, that where the Phragmites had been, they had taken up all the nutrients, and so they were kind of little potential deserts for nutrients.
No, our cages were away from the Phragmites. They were out more in the sheet flow, mud flow, the playas areas. That's where, or pretty much permanently inundated with water. But we were away from the Phragmites, so we didn't look at how much Phragmites takes nutrients out of the water and how that would affect them. But I'm one of those, I'm probably the only person here in the audience that thinks Phragmites isn't so bad. I remind everybody, Phragmites is native to Utah. It's not an invasive species. There's a subspecies that it's interbreeding with that is what we consider the problem, but Phragmites is native. And so it does play a role in macroinvertebrate habitat for sure. So we want to reduce the amount of Phragmites, but I don't think we want to completely eliminate.
Hi, David. Thanks for your great work. I have a question about whether you could expand on management a little bit better and, forecasted volume of water that might be changing in Farmington Bay and how that may affect the availability of the food for the shorebird.
We're looking at that.
Specific?
No, there's nothing more specific. It is a concern, but that's all I could go into saying.
Yeah, in Farmington Bay in particular, the water levels are changing throughout the seasons, and so the dance floor is constantly changing and moving. How did you take that into account?
As far as our food web models?
Yeah. Well, and the goals in particular in their dance and the exposures were,
right.
Did they dry up or?
Actually, sometimes the inside the cages they got dried up, but for the most part they stayed inundated. But you're right, the levels fluctuate a lot. Sometimes it was up to ankle deep. Sometimes it's not quite knee deep, but it does fluctuate a lot. So that is important.
in the midge population dynamics, but we just showed some of the graphs of what those dynamics are, and it has a lot. What was 2022 was midges almost disappeared in the Farmington Bay sites and our study sites, and that was a low water year, and that was when the brine flies were very low too. So there's a lot going on that we're not quite sure what that is, but the thing is too, there was a lot of birds out there feeding on the midges, so we're saying that it was top-down control of the midges, that they were eating all the midges, and so that's why we're finding so few midges in 2022. But the next year, when the water levels came up, of course, the midge population. The thing about midges is that they're what we used to call RAK selected species, right? So the midges are more affected by environmental conditions in their population dynamics, and so they can rebound really quick, or they could disappear really quick. They're not like a grizzly bear that just keeps that steady population and is slowly declining or slowly increasing. But the midge is very highly variable. But one thing that when you're looking at extinction probabilities, once you start seeing more variability in populations, you're getting likely more to go extinct, because once you get that really low fluctuation down to zero, that's what the game is pretty much over. But of course, midges can recolonize from other areas. But once you really start seeing dramatic fluctuations in populations, that's a cause for concern.
Sorry, David. I could not keep quiet. Bite my tongue. It's inaccurate or maybe misleading to say that Phragmites is native, especially for a Great Salt Lake ecosystem. It was much more accurate to say there is a subspecies of native Phragmites, and it is a very small component of the Great Salt Lake ecosystem. And also, there is a ton of genetic testing to prove that. So when people say Phragmites, they're generally referring to non-native invasive Phragmites. And so if we can make that distinction, I'd really appreciate that.
I think that's totally up for debate. Because my point of reference is from, I wasn't around in the old days when ground sloths were walking around in Utah, but if you look at their petrified poo-poo, they have Phragmites in their petrified poo-poo from Utah. And there's still a few populations of the native subspecies, or you want to call it a strain or a variety, whatever you want to call it, that is native to Utah. And I'm guessing that the Native Americans utilize that quite a bit. Yep, I agree. No, it's more to control it so it does its best ecosystem function. Right, we're not going to get rid of carp. We're not going to get rid of white people. So we're all here to. So we're all have to be here to interact and participate in the grand waltzes. And like I think Karen likes to say, is the native Phragmites was a good player. It played well with its neighbors, but so whatever.
Thanks for the presentation and the thoughts through space and time. It's good to think in deep time. And I wondered, you've made comments about the future of Utah Lake and how that interacts with Farmington Bay and Great Salt Lake. And what do you think would be the most helpful changes, particularly in hydrological management of those two systems in Ireland?
Well, I guess the obvious answer is keep water going into them. I don't know what the best management strategy would be, right? A lot of people are concerned about evaporation, and I think, well, that's just the way it is. You get shallow lake ecosystems, you're going to have evaporation. It's not a bad thing. So there's a lot of management strategies we can do for Utah Lake and the Jordan River and all the tributaries coming in Farmington Bay as well. But we'll have to think about what is the best strategy, and there's a lot of people thinking about that. But I've got my own opinions of what we should do with Utah Lake, and people don't like to hear it too often.
I am just obsessed with midges. They're so cool. One time I was driving around and midges got into my truck and they lived in there for about a week. So I'm just very excited to learn about midges. And I have a basic question for you. How sensitive are they to fluctuations in salinity?
Well, we've got several packs of midges out there. We've got the Ceratopogonans, which are the biting midges, right? They're not Chironomous or Tanipus, but the two dominant ones.
I don't like the biting ones as much.
Well, one thing too is people consider midges mosquitoes, and so you've got all these pest control people out there spraying for them, and they're hammering the midges pretty good. But the midges' tolerance to salinity is they're not tolerant to salinity. They can survive in some salinity. They're very susceptible to freezing, and they do all right in desiccation. And their eggs could survive for a while in desiccation. Even the adults, even the larvae can survive a little bit of desiccation, but they're not that tolerant of high salinities, right? You don't find them out in the Gilbert Bay or anywhere else. Like that gets a little bit too much, but they're more of a freshwater species. One thing about midges, there's over 1,400 different species of midges in North America. So a lot of water quality agencies say that midges are bad. When you have midges in your ecosystem, you have poor water quality. You can find midges up in the top of the Himalayas or the top of the Wasatch Range in the pristine tributaries. So that's another misnomer about midges too. So until you start thinking about the midges and learning about them, it's like they go through. There's a whole range of habitats and tolerances and niches that they occupy. So they're pretty cool. They're one of the most diverse families of aquatic insects in North America.
Hey, David. Yeah, thanks so much for your talk. I was kind of curious. I mean, I know that the substrate is super variable throughout Farmington Bay. I was curious if you guys were seeing what your substrate looked like when you were taking these sediment cores, and if you saw variation between your exposure sites.
In the exposure cages, they were a little bit more muddy, right? They accumulated a little more sediments just because the cages kept them from flushing out as much. But it's mostly fine sand habitat that they're in, that where our cages were in and where we're looking. Fine sand, a little bit of sediment, and not much clay, but it's mostly fine sand. So that's what we're looking at. And you're right, Farmington Bay has lots of heterogeneity going on for habitat. If you go out, I don't know if you looked at some of your samples yet, but if you go out to the middle of Farmington Bay where all those macrophytes are, we were counting like 70,000 insects, aquatic invertebrates per square meter in that SAB. So there's a lot of different habitats, and trying to measure all that is one of our challenges, but it's variable for sure.
Yeah, I was curious if you got any of that sludge from the sewage inflows.
Not really a lot of sludge there. No, the thing is, it's pretty much worked through by the midges and this positive feedback loop that we're talking about, so that gets really recycled really fast. So basically, it's really fine sands is probably the dominant sediment. Okay, thanks.
I have one more, sorry. I just wanted to ask, now that it seems like some of the smaller tributaries that used to be bringing nutrients into Farmington Bay, like from the sewer plant, are now being taken into Gilbert Bay along with, the dog and drain. Is there, we're excited about that for the way it could benefit the brine fly population nutrients, but is there a risk of taking too many nutrients out of Farmington Bay to the midge population?
Yes, that's true. That's what we're trying to do some with our functional ecology food web model. And you have to remember too that Salt Lake City just is coming online with their new treatment facility. And they're going to reduce nutrients 10, 20-fold. So there's going to be less nutrients coming into directly into Farmington Bay. As far as the other one up north, that's going into Gilbert Bay. So there's going to be obviously less nutrients coming into that portion of Farmington Bay as well. So that's kind of what our goal is, as I'm contracting out to do, is what is the optimum level of nutrients in there to grow as many midges and bird food as possible, plus also look at the ecosystem function as a whole. So indeed, changes in nutrients. One thing you have to remember too is that there was always nutrients going into the Great Salt Lake, right? But now that we're adding so many more nutrients, is some people say, well, the Great Salt Lake is nitrogen limited. Was it always nitrogen limited, or is this just now something that's going on? So that's kind of the question we're trying to answer.
Do you have notes? Okay. All right, and here's a clicker, printer. Right.
Okay, thanks. Well, it's been kind of a long morning, and luckily the last three talks, including this one, are about Farmington Bay, and a place that we've been studying for a long time. Heidi and I started back in about 2004 when I was with the state of Utah working for DWQ. We hired John Cabot and Heidi. We got a really huge grant from EPA, and Leland matched it with about 70%, way more than their normal match was required. So we got a really nice head start on doing some things, and our initial goals were to, well, it's really simple. Like, can we develop a metric or a system of metrics that can give us appropriate water aquatic life criteria for nutrients? So, and as you can see, we're still struggling with that. And this talk today will show that we're still struggling with that. So, I don't have very many pictures, so I'll show a couple here up front. So this is one of our favorite guys. Great picture. So, and as David has talked about, it's all about the birds. The Farmington Bay is, has beneficial uses are waterfowl and shorebirds and aquatic life in their food chain. And so what we're really trying to do is unusual compared to most other like EPA projects and so forth that have aquatics as for fisheries, for example. So this has been a fairly new challenge to try to figure out how do we connect that system up to birds instead of just up to maybe a top predator fish or whatever. So it's been quite a challenge. Another thing I need to acknowledge, our team has been with us many years. Hannah Finley and Ivan Gadchuk. The bottom two just finished up a really neat master's degree under Bill Johnson doing a groundwater hydrology study, and we're just going to put that together. We're still working on that with Bill Johnson at the University of Utah. So we haven't got that component well enough yet, but that's also, we believe, is a pretty big component of the nutrient budget for the Bay. So I'll just start off by giving a little bit of orientation. Like I say, it's a system of long and winding channels, and so just to give you a little bit of orientation, a lot of you guys know this pretty well, but just to show where we took some samples. Way down here, in this area here is Salt Lake's wastewater treatment plant. Right over here is Chevron's refinery. So they discharge into the northwest oil drain. That comes up and it actually siphons under the river and takes a shot all the way out here. It's just a shot for about 7 miles, 8 miles that goes into, but there's a pretty laminar flow across here and up into the main part of the bay. And this is a pretty recent Google map, so you can see we don't have much more than just a wide, shallow part in in the bay anymore, so, which is tragic. And maybe we're gonna another year or two of high water will get this thing recovered, but when we first started, I remember being over here with Leland, we would take our four-wheelers, and it was 7 miles from this area here, which is just south of the Central Davis plant. 7 miles from here over to here. It's just amazing. So we've lost what I figure about 80% of the surface water of Farmington Bay. So, if you're gonna do a nutrient budget, you have to measure nutrients, right? So what I've done here is just briefly describe, up here is the State Canal, although I measured down here below. But what I'm talking about is what's the original sources, and then what's the final sources that get to the bay itself. And so I won't make you recite what these numbers are, but you see in this case for phosphorus, you have about 0.5 or so in the State Canal. The oil drain has about 1.2 milligrams per liter. And then from there, the water either comes out of the State Canal through the system for the Farmington Bay WMA, or if it comes out this way, right here it comes into the New State Duck Club and then goes ahead and feeds into the turbine unit of the WMA. The water from the State Canal is diverted either down the bypass canal, which we've talked about a little bit, or on down and feeds into the Unit 1 or the Unit 2 of the Farmington Bay. But what's interesting that if you look at what's happening up here compared to what comes out of Unit 1, okay, or what comes out of the Turpin Dike here, you can see there's a fair bit of assimilation, a fair bit of loss of nutrients from the actual water. So I say this is really, these are functioning, healthy wetlands, okay? If you've been out there at all, you would see they're just really thick stands of Stucania, sable pondweed. And I credit that to Heidi. She spent so many years out there. She actually has a system of metrics and strategies to benefit, to manage. We talked about how to manage these things for optimizing the resource. And so we all started this back in the early 2000s, and we've kind of finished up some of that now by about 2015 or so. So, but this is anyway, this is a phosphorus component. Here's the nitrate. I'll separate nitrate and ammonia separately. Same idea, the State Canal, in the milligrams per liter, but when you get out through the end of these impoundments, look at that reduction. It's about an order of magnitude reduction in nutrients as these wetlands process. Now, one exception, of course, if you look at the oil drain, the famous oil drain, these numbers are not different, nor is the number of phosphorus very different from what came out of the pipe. And that's a whole other story. I know some of you guys know that they've worked on this off and on because it's been suggested as a candidate for the Superfund program for EPA. Because they used to just dump lots and lots of nasty stuff all out north of the airport and out to the west. And so, and this started even way before the airport was even put there and expanded. So Ramesh Goel at the University of Utah and I both believe that there's some legacy toxics in the bottom of the oil drain that you'd normally would have maybe after 8 miles, you'd have some assimilation of this, but as we'll see a little bit more, that there's not a lot of microbial activity. Okay, when we talk about assimilation, it's got to start at either the microbial level or the algae level to start assimilating nutrients pretty much, okay? So here's the east side to try to get the entire picture. So here's Central Davis. Their end of pipe for P is not very much. Case Creek is a whole lot less. North Davis about 1.1 for total P. And then we've done quite a number of samples out through here, and this is about 2.5 miles out to this point here. And again, P has already gone down to about 0.36 on the average as it gets through and gets assimilated and starting to enter that ecosystem that David just got through talking about. So pretty exciting to see how You can see how green this is. Also, here's the nitrogen, same idea as far as, so, same idea, nitrogen here, 13 for ammonia, 8 for nitrate. These wetlands really handle it just like the impoundments do. There's a lot of assimilation going on. So, when you talk about a budget, nutrient budget, well, let's talk about what the loading is. And so, I've got lots of different separations here. So these are end of pipe, or in the case of the state canal, what's at the bottom of the state canal before it gets into the wetlands. So when you just multiply those concentrations up, you know, by flows and by time, state canals are pretty good load. And I'll have another moment here too. Anyway, the oil drain, a whole lot more. Central Davis, I've got these asterisks here because this water does not reach the open water. It dries up before it gets there, so you don't really consider that those are adding to that nutrient budget. Well, some could debate to say, well, if the lake comes up, it'll be a part of it. But there's more slides, you can see lots of pictures where we get these dust storms that could blow it away as well. So again, it's one of those things that do you use it or do you not use it? Okay, so, but if we do another calculation and take what's at the end of the sheet flow or the impoundments, how much is it reduced? There's not a lot, but it's done about 87 tons a year, totally from the POTWs, the state canal, and the oil drain. So this is basically the phosphorus. So if I do nitrate and ammonia separately, same idea. Oops, let me go back a little bit, go forward. Okay. So ammonia and nitrogen by itself is really elusive. Any of you worked with, you know, I just really enjoyed Gary's talk yesterday about how they spent a lot of time focusing on the nutrient cycling just between the biotic components. Okay, how fast and perhaps how many times per week, probably if not per day, that nutrient may leave one component of the system and get taken up again by the algae and just re-enter them within the microbialites in the water column. So, so I take this with a real grain of salt. And again, this is tonnage. But it, you know, it's over 1,000 tons of nitrogen come into Farmington Bay from these different sources. And here's ammonia, same thing, about 600 tons of ammonia come in. And so, you know, you could think, oh my gosh, you know, that we're just fertilizing the heck out of Farmington Bay. It should be an absolute mess and so forth. And so, you know, so this is the impression that a lot of us have, or I had, for example, before we got busy looking at what's going on. So, one of the first things we did, and I credit Brad Martin for this is a crusade that Brad and I and David embarked on. So we started looking at what's happening between the sources down here and up to the Syracuse Causeway here. I thought this is another study by Ramesh Goel, also from the U. So keep in mind, you know, these down here we're trying to get a little bit upstream of the oil drain and then see what happens as it moves down through the bay. So the first thing you notice is really easily, like, so site 7 was just downstream from the oil drain. Okay, here it is here. So ammonia, and there's our nitrate. And this is here we have TKN. TKN is basically total nitrogen. It's a digestion of the organic nitrogen or the proteins in organisms and so forth. And this is TN. So you take TKN plus the nitrate nitrite. This will give you a total nitrogen. And then a total phosphorus, here, the same idea. And I don't know why, but maybe a little bit different location, whatever, that we have two sites up here that are pretty high in phosphorus, but anyway, the story is you look right away. So even from the oil drain, it really went down by more than an order of magnitude. Where did all the ammonia and where did all that nitrate go to? Didn't we have many, many, many tons of it coming in? And now the water column just doesn't have any. You know, we're talking about really potentially nitrogen limited. The phosphorus, not quite so dramatic, but I point your attention to, this is total phosphorus, okay? That's total what's in the biota and what's in the water. But SRP, soluble reactive, that's basically what's considered biologically available. That's the ortho. Ortho and SRP are often used interchangeably. But look at this again, you know, compared to the loads coming in, the amount of ortho or biologically available is really low. So what's it doing? It's ending up all the way down the bay, it's ending up in the biota. It's being assimilated, either in the phytoplankton and zooplankton or in the sediments. So, so I equate this, and now let me go back again. So, yeah, pretty busy graph here, but just briefly, you can see, here's our water column measurements of nitrates, nitrites, and ammonia. We're below detection all the time in these samples, and these are from the bay 1 or from the bay 4, and 4 is about a third of the way down the bay. Okay, but we have really not much left. Okay, and here's our total P at about 0.3 to 0.5. And the ortho P is about down to 0.03 or 0.04. So where's it going? Look at this chlorophyll A. It's between, well, there's the number of 5.6 up to 278, 410. So in lakes, if you have over about 35 or 40 micrograms of chlorophyll, you're considered eutrophic. If you're over 50, you're hypereutrophic. So, yep, the bay is hypereutrophic, as we all would know that, okay? So it's all going from the water column into here. Okay, now let's go one step farther. And I'll show some more stuff about this too, but part of Goel's work was, because we know that nodularia was one of the key phytoplankton. It's a cyanobacteria, and it's also a nitrogen fixer, and it's also a toxin producer. So we have a lot of concern about the nodularia, but he did all the sites, but only the northern half of the bay showed nitrogen fixation, which would suggest that it's nitrogen limited. And we talk about that. So if you get low on nitrogen compared to phosphorus, and we believe we are, it may not be as bad as what you might think, but it is nitrogen limited. So you favor those organisms that can fix a lot of nitrogen, and therefore they can become favored, right? They can be dominant. They can have an advantage over those that can't fix nitrogen, so they can keep on growing. So are we finished? No, not yet. So we started doing this just a few years ago. Major program was around Utah Lake. And we're still in a state of controversy about how much atmospheric deposition hits Utah Lake or Great Salt Lake. And we've done 5 years at multiple sites in multiple ways of measuring atmospheric deposition to demonstrate that even after Farmington Bay shrinks, it's normally about maybe 80% the size of Utah Lake if it's full. But if I cut that down by 80%, you have 52 more tons coming in from AD and 414 tons, 407, whatever it is, coming in from nitrogen. So there's another shot in the arm. But did that make any difference really to the whole system? Not so much, okay? There's a thing we're looking at. You know, we say that Sediment recycle from Utah Lake, and this is another controversial thing on how you measure it and how you do the endpoint. One publication by Mitch Hogsett, who worked under Mescawell, showed 1,500 tons of phosphorus can enter Utah Lake. Cut that down by 80%, 300 tons can enter Farmington Bay. Is that a real number? Well, we don't think so, because we know there's sediment recycling. So if it comes out, for example, we know that Utah Lake, 90% of the phosphorus coming in stays in. It doesn't go out the Jordan River. So 90% of Farmington Bay's phosphorus stays in the bay. It doesn't go out into the South Arm. So it's accumulating in the sediments. So this is kind of a misnomer, or maybe misidentified. What we believe in the process, though, if it recycles, and we've got two papers, and Leland played a part in one of this way back in about 2008, where, for example, if you're practicing trying to reduce the eutrophication, what if you reduce nutrients from the POTWs? Or what if you reduced it by dilution, by doubling the volume of Utah Lake, or doubling the volume of Farmington Bay? You're diluting the nutrients by half, right? So it can happen, but what happens if you do that? Well, it's very likely to come out of the sediments because there's so much nutrients built up in the sediments. And I'll show you that in a second. So here's the Utah Lake data, and this is really fascinating. This is work by Gus Williams at BYU. So this is the volume, not the area or the depth, but the volume of Utah Lake since about 1989, and it goes up to very recent times. And so this is just the ebb and the flow of precipitation, how much water comes in, right? But here's the point. If you look at not just total phosphorus, but if you look at, we call this dissolved phosphorus, but I know in the data he used, which was DWQ data, which is supported by some of our data, it's ortho. It's still the same as SRP. So despite these huge changes by more than 50% sometimes, what happens to the bioavailable phosphorus? Okay, you think, oh, if you double the volume, well, you should have diluted that, right? Nope. So we believe it's coming out of the sediments. And if you dry up, so you have it more concentrated, for example, from evaporation, nope, it stayed the same. So we believe that sediment layer is a buffer. So if the lake gets diluted, or if you cut discharges back a little bit, oh, we're saved. Well, not so quick, because the sediment is a huge reservoir of available phosphorus and even nitrogen. So this is where we get into the tug of the battle of how do we really develop a nutrient budget to manage a lake like, sure, for first the Utah Lake. Okay, but this is one of the huge variables that we have to wrestle with when we do these things. So when you have this kind of data over 30 years and the population during that time in Utah County about doubled, okay, well, the sky's falling, we're going to have double the phosphorus coming into the lake. Well, it didn't double even then, but the orthophosphorus, the SRP phosphorus, it didn't move. It didn't go up a bit. It wiggled around a little bit, and I can tell you, because in 2023, I was out on Utah Lake, and we took a number of samples. When runoff was coming in, the lake volume doubled last year. It went up 3.5 feet up to compromise. Didn't overflow very long, okay? So total phosphorus went from 0.08 to down to about 0.03, 0.035. It was diluted by half. In the next 6 weeks, 4 to 6 weeks by July, even though runoff is just barely pairing off, the total phosphorus went back up to 0.08 again. Okay, so we believe that, well, it's just a buffer. If you have lower concentrations in the water column, it comes out of the sediment. If you have less concentration, well, less if you have more for evaporation, the sediment can be a sink. And we have data that shows, like Utah Lake, you can add 10 parts per million of orthophosphorus to Utah Lake sediments, and it'll take up 90% of it to the sediments. Okay, so it's a really good buffer. I'm getting close. So, here's just a quick review of atmospheric deposition. This is our first layout. This is pretty cool. So this is a dry side bucket, and this little panel here, we activate it where we support a battery that has a moisture sensor. So if it gets wet, this moisture sensor gets wet, it switches an activator, so this panel comes over and covers up this bucket here, and you get rainwater. Okay, so you can get wet and dry deposition is what I'm going at. These failed after the first couple of years. They were not that reliable, so we just started, we always had about 4 liters of water in here, so so what we're talking about is you get the rainwater, you get the dust settling, and also we know that this contact of the dust and aerosols with water, it's sticky. So on lake surfaces, it'll grab it. So we started doing all of these 3 different things that it also is debated on how to do atmospheric deposition. Here's our sites on Utah Lake, and we do have 2 sites on Farmington Bay, so we can use the data, right? And the whole thing, and the 2 watersheds are very, very similar. Sediment P is very identical and that sort of thing. And we all know about the dust storms, right? So here's these episodic events. This is just the total phosphorus that comes in from the dust. You get an order of magnitude or more during these dust events. When that dust is mobilized, it really carries a lot of nutrients with it. Okay, I'm almost done. Let me tell one more thing. 1 more minute. So the end result of this whole thing was to try to control nodularity. You don't like the cyanobacteria blooms, right? So as I looked at the last 2 or 3 years, I was going, oh my gosh, even though the lake level was approaching the record low of 2022, we were getting just no blooms. And certainly after the big fill-up came last year, very, very low numbers, right? And I'm thinking, wow, maybe it's just the dilution, it's out of the sensitivity range for salinity, it doesn't like to have anything more than 5,000 or less than 3,000 for TDS. But before that, and starting from 2020 all the way back, and this has gone back even to early 2000, but we get these occasional blooms, and here comes the nodular, which is a microcystin, and you know the EPA's recommended warning is at 8 micrograms, and the sky is falling is about 2,000 micrograms, and so we occasionally get up to 218. We have a 156. So we do get these that are episodic. They're not really scary, but we do get those, so that's the concern for Farmington Bay. But anyway, the point is that we're not sure yet, but right now it might be that it's being diluted out of the salinity range and or the residence time, just flowing like a river going through the bay. And this is just a picture, if you can see it. This is the little critter, that's Nodularia spumigena, and these things are little heterocysts, and that's where nitrogen fixation is occurring. So that's it. Wow, I was that good, okay.
Hey there, this is David Richards. You think eutrophication is a bad thing? Is eutrophication a bad thing?
Isn't that a great question? You know, if I could have gone another 10 minutes, I would have, because we could talk about just that, because the end point of what we're talking about is sometimes there's a conflict in values, right? Well, you know, we don't like the nodularia, we don't like the blooms on Utah Lake, but I'll maybe preach a little bit. And I'm going to refer back to Gary Belofsky's talk yesterday. And I think Farmington Bay, it's a really good analog of the South Arm. I think these ecosystems in Farmington Bay and in the South Arm are so high-tuned and they're just efficiently transferring nutrients up and down, in and out. You know, we know that bacteria can double their population every 20 minutes, so these microbes can really take up and grow and reproduce and get eaten again and remineralized. And so the question is, if you have an ecosystem, in the case of the South Arm, what's the end product? Oh, we really like brine shrimp. They're economically valuable. They're ecologically valuable. What's the downside, right? There's no downside. And in fact, the Great Salt Lake Great Salt Lake shrimpers want to have more nutrients because they can benefit from that. And you could say that the birds could benefit from that. And that's why I like to do research on the birds, you know. Farmington Bay is the same way. When David talks about there's fewer midge pores, you know, inside or outside versus inside. Are we approaching the carrying capacity of the birds in Farmington Bay? Maybe. Don't we want to know what that is? Yeah. So there may be a conflict between the nodularia are nasty, you know, but I'm telling you, the blooms are done before duck season starts, okay, so the duck hunters are safe. You know, and we, you know, and they only occur in the northern, about 25% of the bay. So they're very restricted in that ideal salinity and temperature and nutrient range and so forth. So anyway, the bottom line is, these things become so complex with the conflicts of what the values are. And our values as humans obviously are very, you know, we're very subjective. We know what we want, right? Sometimes you say, well, to hell with the birds or to hell with the fish, you know, but no, these are things that we have to deal with. So anyway, the short answer is eutrophication oftentimes is not a bad thing, especially when you can optimize shrimp production, optimize midge production to feed the birds, and of course now feeding the people of the world. So that's my short answer.
Good morning, I'm Mike Conover, a professor at Utah State University. For about the last 20 years, I and my grad students have been studying bird use of the Great Salt Lake. We focus primarily on birds that are used in the pelagic bays, where the brine shrimp and brine flies occur. That's primarily the eared grebes, Wilson's phalaropes, redneck phalaropes. And as we've learned, the Great Salt Lake is a critical resource, by far the biggest hypersaline lake. And what happens on the Great Salt Lake impacts the continental populations of those species because such a high proportion of them spend the summer or fall on the Great Salt Lake. And so it's important. There's another species that we should add to that list where the Great Salt Lake is having a huge impact on a species survival, and that's cinnamon teal. So what I want to do today is send your attention a little bit further east to look at the bays on the east side of the Great Salt Lake that have water that's brackish, the sheet flows, and to the waterfowl management areas, the refuges that are in the deltas that have been created where rivers flow into the Great Salt Lake. The areas I work are the same places where Lauren Head works. We're working basically where we have these deltas. The deltas have been, impoundments have been created there by creating shallow or low-lying dams, created impoundment a few feet deep, and those areas are managed for the benefit of water birds. I want to start off today and talk about where duck nesting populations currently occur, what their status is, to look into the future, especially given the impact of climate change that's occurring. But I want to start and put that into a historical context to show you what the Great Salt Lake used to be like, so we can compare what's happening today to what has historically occurred in the past. Prior to the 1980s, the Great Salt Lake and the marshes around it were known as a duck factory. We had tens of thousands of duck nests out there. There was only one mammalian predator that bothered the nest. Very few birds did. That one mammal was striped skunks. There weren't very many out there, but there were so many duck nests, so many eggs, that the skunks could eat as many as they wanted, and there were plenty of other nests that were successful where the eggs hatched. And so nest success was very high, around 50% prior to 1980, just because there were so many duck nests out there. Things changed in the early 1980s. There were two events that happened simultaneously that impacted nesting ducks along the Great Salt Lake. One of those were the floods in the early 1980s. All of these impoundments, waterfowl management areas were all flooded because the lake rose so high that the hypersaline water from the Great Salt Lake flowed into these areas, killed all the vegetation, wave action destroyed the dams, so everything was lost. During those years, the ducks that used to nest here couldn't. They all moved further north into the Flyway and nested in the northern US or Canada. Well, the floods only lasted a couple of years. Once they were over, we rebuilt the dams, reflooded the impoundments. The vegetation took longer to adapt because it had all been killed, but it eventually did. So we got the wetlands to where they used to be, but duck populations have never responded. After the things were back to normal, a few ducks came back, tried to nest here, and they had no success. One of the reasons for that is the other change that occurred in the 1980s is that red foxes and raccoons expanded their range northward. So for the first time, they were occurring in northern Utah, including the marshes of which I'm speaking. Skunk populations also increased after the 1980s, so when the birds came back, they didn't find the predator-free environment that they had before 1980. Now they're trying to live in an area with a lot of predators out there, and there's no longer 10,000 duck nests to spread it out. So all of the predation is concentrated on the few nests that occur here. So it's a tough situation. The species that nest here, there are three main gathering ducks that occur. Those are cinnamon teal, mallards, and gadwall. For the mallards and gadwall, the heart of their breeding range is the prairie pothole region. There are millions, estimated 5 million mallards, continental-wise, 2 million gadwall. What happens on the Great Salt Lake? It's important locally, but it doesn't have an impact on the continental population of those two species. It's different for cinnamon teal. There were probably never more than 300,000 existing in North America, and that's the entire range of this. But if you look, they are not in the prairie pothole region. In fact, they're just in the western United States. And if you locate the Great Salt Lake on that map, we are the heart of that breeding range, which is the orange. We were also the heart and center of the nesting population of cinnamon teal because of the 300,000 birds that existed prior to 1980. Approximately half of them were nesting in the marshes where I'm working, the marshes around the Great Salt Lake. Half of the entire population were here. More recently, counts estimate that there's now probably 10 million cinnamon teal nesting throughout the the state of Utah. And so the population that's nesting in the Great Salt Lake and the marshes is estimated to be less than 10,000. Went from 150,000 to 10,000. Let's talk about what's happening in the future. Here is a map of global warming in the western United States. When climate changes, if you notice, northern Utah, where the Great Salt Lake is predicted to become warm, one of the warmest spots in the continental United States. And it's supposed to become drier. In addition to that, climate models suggest that climate extremes will become more common in the future. But we don't need to look to the future to see that trend. Let's just look at the last 5 years. In the last 5 years, in 2019, we had record spring rain that year. Highest snowpack was normal, but in the spring, during the months of March and April, more rain occurred than it ever occurred in Utah in that year. That was followed by one normal year, 2020. That was followed by 2 historical droughts. And as you know, in 21, 22, the Great Salt Lake dropped to its historic low. 23 saw another historical event. This time it was the level of snow. We had more snow on the ground in Utah than has ever been recorded in the past. And so in these 5 years, we have set 4 historical records. 2 with high precipitation or snowfall, 2 with droughts. So let's see how the ducks have done during these years. Well, if we start looking at nest initiation dates and clutch sizes, what I have done here is the wet years. I've got those highlighted in green. The drought years are in red. The one normal year is in black. If you look at the date of nest initiation, there's no change. No matter what happens climate-wise, these guys are always starting to nest on the same days. That's a little scary because it suggests that at least as far as nest initiation, they are set on those days and they're not changing based on current conditions that exist that year. If you look at clutch size, this is the number of eggs in a clutch. That's also a significant difference across those years. It ranges from a high, if you look at the 2 green years, high clutch levels those years. Look at the drought years, it drops. So climate extremes is affecting the clutch size of these birds. Here is duck numbers. We run the same transects year after year. We've done that for many years now. Here's the records for these 5 years in the transects that we're looking. Compare the green years to the red years. What you see is, for instance, for cinnamon teal, we had 267 nests along our transects during 2019. During the drought years, it was 20 and 59. The same trend occurs in all of those species. They don't. Nest numbers drop during years when it's dry, rise when precipitations increase. What's happening to the fate of these nests? We follow these nests to determine how many were successful in fledging at least one duckling, how many were depredated by predators, how many were abandoned. We check these nests basically weekly to look at their fate. We have nest cameras out there so we can determine what's happening. And as you see, let's look at the success rate. When were the nests successful? Well, gosh, we had 45%. That's a pretty high level during the first high precipitation, 39% during the last. Look at the drought years. Almost no nests were successful those years. The reason for that is if you look at the number of nests that were depredated by predators, almost every nest during the drought years were hit by predators, primarily skunks and raccoons. Here is an example. These are 75 nests where we have nest cameras out. We recorded the predator that was depredating from our photos. Of those 75, there's a lot of things that like to eat duck nests. So there's a lot here: gulls, harriers, foxes, coyotes, cranes, weasels, skunks. But if you look at raccoons and skunks, that's 61 out of 75. They are the ones that are having the impact upon nesting success. The other predators take one here or there, but it is skunks and raccoons that's depredating these nests. We also went out to these areas. We put cameras on the bridges. Bridges represent choke points. If you're going from one impoundment to another along the dam, you've got to cross the dam. So what we've done is we go out, put nest cameras up, leave them for a couple of weeks, and see basically how many predators are out there, what they're doing. I only have results for 3 years, one drought year, one normal year, and one 2023 when we had record snowfall. What you see is in 21, 20, we were seeing 300 or so predators cross these bridges. That doesn't mean that there's 300 individuals, because I can't identify individual predators. It's an abundance. But compare that to 2023, the wet year. Then we only had 6 skunks compared to 10 times that many during the drought. 56 raccoons compared to 200 plus. So what happened in 2023? Why aren't there predators there? The answer is that the snow levels in these impoundments, in these reservoirs, or the different marshes out there, the snow levels were so high and the snow lasted so long that we had a major die-off of raccoons and skunks that year. So there weren't predators out there. And for the first time, I could go along our transect, and one nest after another was successful. The predators were simply not there. Without predators, boy, did the ducks have a great year. So here's our findings. We found that duck numbers and densities were positively correlated with spring precipitation. Probably what happens is these birds are moving north through the flyway. They come to the Great Salt Lake. This is the first place they're thinking of nesting. If the vegetation is abundant, if the impoundments are full, things look great, more of them will nest here. During drought years, they didn't find conditions they wanted. They moved further north in the flyway. They didn't stop here. Predator counts were negatively correlated with local snowfall. Nest depredation rates were negatively correlated with local snowfall too. Snowfall impacted predators, that impacted nest success. And nest depredation was positively correlated with raccoons. So what we have here is we have a situation where we used to have half the cinnamon teal in the Great Salt Lake marshes. I don't know what percentage is here now, but it's certainly much less than 10,000. These are gorgeous birds. They are gaudy with colors. And the survival of this species depends in large part on what's happening here in the Great Salt Lake. So when you're thinking about the species that are dependent upon the Great Salt Lake in the marshes, and we're thinking about phalaropes and eared grebes, think also of these cinnamon teal, because this used to be the heart of their breeding range. And no species can, or it's a concern, if half the breeding range of a species has been lost. That's the end of my presentation. You can go if you want, but for those who want to stay, I'll play a game with you. I'm going to show you nest camera photos. These were taken in the Bear River Migratory Bird Refuge. Well, I want to see you think about it. Can you see the predator in this picture? Do you know what it is? Well, the answer is it is a raccoon, and it's there on the right side, that furry thing. It looks like a plant where they all come together. That's the fur of a raccoon. How about this one? You see the predator? It is this strange looking object in the beginning on the right side. I know that because it wasn't there in the photos that were taken a few minutes earlier. That is a raccoon. How about this guy? You see him? Do you recognize him? Well, you can see his eyes and his face again on the right side. That's a skunk. It gets more difficult now. What's this guy? Can you see it? Do you know what it is? It's again on the right side. I guess every predator likes to enter on the right side. One of my amazing discoveries. That is a long-tailed weasel. His face is turned away. They're one of the species that takes these eggs and ducklings. And you're looking at all these dark photos. So here's something that really surprised us. Holy cow, this thing was bright, and what the heck is that? It looked like a dinosaur. That really startled us when we used to splint in black and white pictures. You know what that is? That is a sandhill crane. And they're not taking eggs. We've never recorded that. But there are ducklings in this nest, and he's eating the ducklings. So that is the end of our slideshow. You all get a prize because you all got all of those right. I'm so proud of all of you. If you did get them right, come see me because we have a great job for you. We have 10,000 more slides to go through. Thank you very much.
Well, the time has come for lunch, so I won't hold you back, but wow, we've learned a lot this morning, and there's a lot more left this afternoon. So you can find lunch through those double doors. We'll be back in 1 hour, and we will be ringing a lunch bell to make sure everyone makes it back in time for the afternoon session. Okay, thank you.